one, and action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, but I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
Ladies and gentlemen, please take a moment to locate your nearest fire exit. In the unlikely event of an evacuation, please follow the directions of the CCD staff and proceed directly outside. Please do not attempt to re-enter the building until told that it is safe to do so.
Hello, hello. Good morning, everyone. Oh, I don't see the same smiles as I saw yesterday, I don't like this. Is it official hangover day today? It looks like it. Well, oh, so you missed it already. That's it. Oh, well, that's good. That's good news. All right. Ooh. Perfect. So, well, welcome to day 3 of EuroPython. I hope everyone had fun last night. By the faces, I judge that you did have loads of fun last night. Very good. Thank you so much for joining us this early here again today for, well, the last day of fun, right? I mean, we still do have 2 days left, but, well, the last day of talks. Cool. So, again, first things first, we strongly recommend the use of masks, especially on rooms that have loads of people. There's hand sanitizers available throughout the building. And please, if you had to swap or if you have a new badge, just remember to go downstairs and grab your social distancing stickers, just so people can know better how to approach you. Then I also would like to remind you that the source of truth of the schedule is on our website. There is a speaker breakout room that happens at Leafy Boardroom 4, and that's your opportunity to have a chat with the speaker of the session you've just been in and ask your personal questions, or go with the, you know what, I don't really agree with what you said. So that's the time to say it, Oh, sorry. Also, please join Vanueless. Cool. So going for today's events, we have open space happening on Wico Hall 2A at 11 a.m. If you're interested on joining or knowing a little bit more about volunteering with us for next year, please join VB just to chat a little bit about it at the open space at 11 a.m. Then we have a typing and speed up Python event happening as well at 12. Then there are dev tools, I think it's a discussion, but I'm not 100% sure, happening at 2 p.m. And, well, you can also propose more stuff when you just pass by. Cool. So then downstairs at the forum, we have a full house of makers today with the Northern Ireland folks from the Raspberry Jam, the Microbit, and the Maker Meet people. Then the PyLadies lunch happening at level 5 at 1 p.m. with everyone else's lunch. But if you're a PyLadies supporter, if you want to know a little bit more about it, if you want to come for a chat, it's not only for females. You're more than welcome to attend. And then for the fans, at 3:05, we have a book signing event with Luciano Ramalho happening. So if you happened to bring your 900-page Fluent Python book with you on the airplane, yes, and you're looking for an autograph, that is going to be the time. And I also heard through the grapevine that we're going to have a giveaway. So I think it's going to be fun. Cool. Then yes, about the t-shirts. So we asked you when you purchased your ticket if you're interested in a t-shirt. If you ticked that box and said yes, please go downstairs and pick up yours. If you have happened to pick up your t-shirt already and it doesn't fit you, just please head to the registration desk and change it. And well, the remaining ones we are going to sell. So after lunch, if you haven't ticked that box and said you wanted one, you can just go downstairs and purchase yours. And then for the volunteers in the room, please just pick up a t-shirt, your t-shirt as well. It's yours. Just be part of the team. Cool. Yes, and then I just would like to please remind you to be gentle with the doors when you're entering or leaving the rooms for the talks. Yeah, as silent as you can, please. Cool. Then finally, we will have the sprints weekend. So the day of talks ends today, but then tomorrow and the day after, we're going to have sprints. So if you have a project you'd like to sign up, please just head to that link and sign up your project. And it's also a lot of fun. Cool. And then again, quick reminder, if everything gets too much and you need a little bit of peace and quiet, just head to Wico Hall 2B for the quiet room. And again, please, if you have any suggestions, if you'd like to let us know anything, please just grab a yellow t-shirt person and tell them your thoughts. Be nice, please. Yeah, we're collecting feedback from everyone, and we truly appreciate it. A special thank you to all of our sponsors. Also, yes, if you haven't been downstairs collecting your swag and their sponsors at the forum, please do. It's the last day. And yes, finally, thank you so much again for joining us so early. And well, have fun. Enjoy your last day. Thank you. And then, thank you. And then now, I'm going to call Larry, who's going to introduce our last keynote speaker of the conference. Thank you. Larry?
Thank you. So I can't find an authoritative source for when we had the first multi-core computer ever. First multi-CPU computer. I know I had one in the mid-90s, dual Pentium. But the first multi-core single CPU was in 2001. It was an IBM PowerPC. And I think servers and desktop computers went multi-core about 2005. The first multi-core phone was 2010. The first multi-core eyeglasses were 2015. And today you can buy a Raspberry Pi Pico for $4. That's about the size of a stick of gum, and that has a multi-core CPU on it. So we live in an increasingly multi-core world. The world is just saturated with multi-core processors at this point. And right now, Python is not particularly well poised to take advantage of that because you can still only run Python code on one core at a time in one process. About 6 or 7 years ago, I started on a project I called the Galectomy, which is the superior name. But the galectomy, the goal was to remove something inside of CPython called the GIL, which is simultaneously something that it relies on very heavily, but also the thing that prevents us from taking advantage of multiple cores at the same time. I pushed the project for a couple of years. I got it to a certain point, and I sort of got tired of working on it and put it on the back burner and worked on other things. I hit really hard performance wall where I just could not surmount. And I was thinking about reviving it a year or two back when I got an email from a guy named Sam Gross, who was working on his own GIL removal code, and he was already far more successful at it than I was. It was so heartening to see because it meant that I didn't have to touch this thing again. So I'd like to introduce Sam to talk about his work. Ladies and gentlemen, Sam Gross.
And, oops, now for the customary AV break. There we go. Yes? Which slides? 1 second. Oh boy. Sorry about this. Wrong way. Make this full screen. Thanks, Larry, for the introduction. Hi, everyone. I'm Sam Gross, and I'm here to talk about my project that I've been working on for the past few years to let Python run multi-threaded programs without the global interpreter lock. I'd like to start with a bit of background on multi-threading and Python's global interpreter lock. Multi-threading, using multiple threads, allows an individual program to perform multiple tasks at the same time. Threads are useful for two related reasons. First, threads can exploit the parallelism available in multiprocessor and multi-core computers. Threads can run on separate cores, so a program that can divide its work into multiple tasks executed by separate threads can run faster on a multi-core computer than if it used a single thread. The second reason is that threads can be useful for structuring concurrency, even on a single processor system. Threads might be used to handle multiple requests in a network server, to overlap I/O with computation, or to perform long-running tasks in a graphical application while keeping the user interface responsive. Threads aren't the only way to structure concurrency. For example, modern Python includes the async I/O package to structure concurrent asynchronous code. But this project is mostly focused on the first reason. We want Python to be able to take advantage of the parallelism available in multi-core computers by making multi-threaded code run more efficiently. One of the big obstacles to efficiency is that the global interpreter lock, or GIL, ensures that only one thread can run Python code at a time. When Python was first publicly released in 1991, it didn't support threads or have a global interpreter lock. Support for threads was added about a year later, in 1992, together with the GIL. For context, the 1990s saw a number of operating systems add better support for threading and support for computers with multiple processors. I think there's an interesting analogy between the introduction of threads in Python and multiprocessor support in some of these operating systems. At least in the cases of Linux and FreeBSD, support for multiple processors was accompanied by the introduction of global locks, the big kernel lock in Linux and a lock called Giant in FreeBSD. In the original implementation, the big kernel lock ensured that only a single thread could enter the kernel at a time, somewhat similar to the way that Python's global interpreter lock ensures that only a single thread can run Python code at a time. Over time, the uses of the big kernel lock were gradually replaced by fine-grained locking and other techniques to improve scalability. The big kernel lock was completely removed from Linux in 2011. From a technical perspective, the global interpreter lock made sense for a few reasons. First, it's simple to implement. It doesn't require a lot of code. Second, the global interpreter lock is really efficient for single-threaded code. The lock is only rarely touched, so it doesn't substantially affect performance if you only use one thread. Third, the global interpreter lock avoids a lot of the potential deadlocking hazards of using multiple fine-grained locks. In particular, the locking discipline for the GIL is pretty straightforward. You need to acquire the GIL once before calling into Python code, and you should release the GIL before calling an operation that might block the thread. Finally, the global interpreter lock still allows for some parallelism. C extensions can release the lock around long-running pieces of code that don't access Python objects. We're now about 30 years after the introduction of threads to Python, and as Larry mentioned, the computer hardware landscape has changed. Multi-core processors are in desktops, laptops, servers, smartphones, and today I learned they're in glasses as well. In server environments, it's common to see computers with dozens of CPU cores or more. Especially as the core counts increase, it's difficult to take advantage of multi-core parallelism from Python due to the GIL. Even with the GIL, there are a number of ways to parallelize Python programs today, but they all have substantial limitations. First, in C API extensions, you can parallelize operations internally in a way that's invisible to Python. For example, scikit-learn uses OpenMP to parallelize its k-means operation. When you call the scikit-learn's k-means function from Python, scikit-learn distributes the work to a number of threads, waits for those threads to finish, and aggregates the results and returns back to Python. This works well when individual operations are large enough to be efficiently parallelized, but not when there are a lot of small steps. A lot of scientific computing libraries, like scikit-learn, PyTorch, and some versions of NumPy and SciPy use this technique. Second, C API extensions can release the global interpreter lock around long-running operations so that multiple operations can overlap. The previously mentioned scientific computing libraries do this, but it usually doesn't scale well beyond a few cores because contention on the GIL quickly becomes an issue. You can also use multiple processes, including through Python's multiprocessing library. Processes are like a heavyweight version of threads. The main challenge with processes is that communication between processes is usually more expensive and more difficult than communicating between threads. I'm going to expand on this point. With processes, objects need to be serialized to be sent from one process to another. You can't share Python objects directly like you can between threads. This is a performance issue because serialization is expensive and requires making extra copies. It can also lead to usability issues because not all objects support serialization. Additionally, many C and C++ libraries you might want to use from Python don't work well across processes, even if the libraries support multiple threads. Some libraries have opaque data structures that might be difficult or impossible to share between processes. Removing the global interpreter lock is a challenge because besides the actual removal of the lock, you have to make Python safe to run with multiple threads. You have to address things like reference counting. Python primarily manages memory by keeping track of the number of references to each object, and the current implementation isn't thread safe without the GIL. You also have to figure out how to handle concurrent accesses to Python's collections, things like dictionaries, lists, and sets. Once you remove the GIL, unless you've made other changes, concurrent modifications to things like dictionaries would crash the interpreter. There are a lot of other internal components in the Python interpreter that need to be made thread safe. Many of these are easy to fix and only require small changes, but others require more substantial changes. Some of the specific internals I want to talk about today are Python's built-in memory allocator and the cyclic garbage collector. Finally, all these changes need to be made while keeping good single-threaded performance and while allowing for efficient multi-threaded scaling. This project isn't the first attempt to remove Python's global interpreter lock. I'm aware of 3 previous attempts in CPython. The first was in 1996 when Greg Stein released his free threading patch. The patch used atomic reference counting on Windows and a global reference count lock on Linux. List and dictionary accesses were protected by mutexes. Parts of the patch were actually adopted upstream. In particular, it introduced a pythread state structure and correct per thread exception handling, both of which live on in Python today. The second attempt I know of was Python Safe Thread by Adam Olsen in 2007. Adam pursued an interesting design. Most objects were owned by a single thread, which could use normal reference counting operations. If another thread needed to modify the object's reference count, it would have to pause and wait for the owning thread to give up ownership. The implementation also had restrictions on sharing objects between threads. You could share immutable objects, like numbers and strings, and some special objects, like a new shared dictionary type. Trying to share other mutable objects, like a regular dictionary or list, would raise an exception. The most recent attempt to remove the GIL from CPython is Larry Hastings' Galectomy, which started around 2016. The Galectomy used atomic reference counting for objects and later versions experimented with buffered reference counting to improve performance. The implementation used locks to protect accesses to lists and dictionaries. The Galectomy was the effort that had the most influence on this project. I had seen Larry's PyCon talks on the Galectomy, where he described parts of the implementation and the performance challenges. I think the biggest takeaway from these previous efforts is the recurring challenges due to reference counting, both in how it affects single-thread performance and efficient scaling. Reference counting is by no means the only issue you have to address when removing the GIL, but it's essentially the first problem you have to solve because the performance impact is so large. A number of people have come to the conclusion that reference counting is the biggest obstacle to removing the GIL, and that we should ditch reference counting and replace it with a trace and garbage collector. So why not ditch reference counting? The primary reason is that getting rid of reference counting would make it much harder to get a reasonable degree of compatibility with existing CAPI extensions. I think the effort to get a reasonable degree of compatibility would probably be bigger than just directly dealing with the issues that reference counting poses. The most straightforward way to make reference counting thread safe is to use atomic operations. The problem with this strategy is that atomic instructions are slower to execute than their non-atomic counterparts. For example, if you modify Python to use atomic reference counting and run the PyPerformance benchmark suite, the benchmarks take on average about 60% longer to run. This chart shows the slowdown of using atomic reference counting in each benchmark in the PyPerformance suite. There's big variance in individual benchmark performance, so don't treat the 60% number as particularly precise. A few benchmarks aren't affected by the reference counting change, while others take more than twice as long to run. Biased reference counting is an algorithm created to address the overhead of atomic reference counting. It was created by Jiho Toy, Thomas Schul, and Joseph Torres at the University of Illinois at Urbana-Champaign, and published in 2018. It's based on the observation that most objects are only accessed by a single thread, even in a multi-threaded environment. Their version was implemented in Swift, but the same technique can be applied to Python. Biased reference counting works by splitting the reference count field into two parts, as well as storing the ID of the thread that created the object. The first part of the reference count field stores the local reference count. The thread that created the object uses plain, non-atomic operations to modify that local reference count field. The second field stores the shared reference count. Other threads modify the shared field using atomic instructions. The true reference count is the sum of these two fields. Because most objects are only accessed by one thread, the technique avoids most atomic operations while still maintaining thread safety. Here's a basic implementation of incrementing the reference count using biased reference counting. The algorithm checks if the object's thread ID matches the current thread ID. If they match, the algorithm increments the local reference count field using normal, non-atomic increments. Otherwise, the algorithm increments the shared field using an atomic operation. This is faster than just using atomic reference counting because, at least on current hardware, the extra comparison to check the thread ID is cheaper than the cost of an atomic increment. This technique has some similarity to the strategy used by Adam Olsen in the Python Safe Thread project. Both associate a Python object with the thread that creates it, and that thread uses fast non-atomic operations. However, biased reference counting avoids the blocking operation present in Python Safe Thread, where a different thread accesses the object and has to wait for the original thread to give up ownership. Here's an updated version of the previous chart. Atomic reference counting overhead is still shown in blue. Those are the same results as before. Biased reference counting is in green. The overhead of biased reference counting is much less than the overhead of atomic reference counting, although it still has some extra overhead compared to the regular non-thread safe reference counting that's currently implemented in Python. Using Python 3.9 as a base, biased reference counting is about 10% slower on average across the PyPerformance benchmarks compared to that 60% slowdown we saw with atomic reference counting. While biased reference counting does a pretty good job of reducing the execution overhead of atomic reference counting, it doesn't address the scalability issues when multiple threads frequently modify the reference count of the same object. To expand on this, I'm going to make some generalizations about how memory operations scale on modern computer systems. This table is divided in columns between operations that are read-only and operations that modify memory. The rows are divided into private accesses, that's memory that's accessed only by a single core, and shared access, memory that's accessed by multiple cores. The check marks indicate if the operations scale well as the number of cores increase. The first thing to notice is that read-only accesses scale well with lots of cores. Memory reads from multiple cores, both to the same location, scales well as reads to different locations. The same data can exist in the cache of multiple CPU cores as long as the data isn't modified. The second thing I'd like to point out is that write operations scale well if the data is private. In other words, multiple CPU cores performing write operations scale well as long as they're to different memory addresses, or more accurately, to different cache lines. This includes atomic operations. Things like atomic increment and decrement are slower than their non-atomic counterparts, but both atomic and non-atomic operations scale well if the data is private. Finally, concurrent modifications to shared data doesn't scale well. So for example, lots of threads concurrently modifying the reference count of the same object won't scale well on multi-core machines. This is relevant for Python because there are some objects that are necessarily shared between threads and they're frequently accessed. For example, the constants none, true, false, some small integers, and some other objects are shared by all threads in a Python program. Like other Python objects, they're also reference counted, even though they can never be collected during the lifetime of the program. Absent other changes, reference counting on these objects would be a bottleneck for multi-threaded programs once you remove the GIL. The fix is to skip reference counting on these objects. The objects are marked as immortal using a bit in the reference count field. The reference counting code is changed to be a no-op if the immortal bit is set, and the objects are kept alive for the duration of the program. This works well because things like none, true, and false already stay alive for the lifetime of a Python program. Immortal objects aren't a new idea. They're used in the Swift, as well as some alternate Python implementations like Cinder and Piston. To go back to the scaling table, immortal objects work because we've transformed writes to shared data to read-only accesses. We've gone from modifying the reference count fields of objects like none, true, and false to only needing to read that field to check if the object is immortal. So why doesn't Python already use immortal objects? Well, for single-threaded code, immortal objects aren't a clear win. The cost of the extra branch to check if the object is immortal is typically higher than the work saved by skipping the reference count operation for single-threaded code. At the Language Summit, however, back in April, Eddie Elizondo and Eric Snow presented an implementation of immortal objects with smaller costs than previous efforts, so we might see immortal objects in CPython independent of any GIL changes. Early on in this project, I decided to test out the implementation on Larry Hastings' Fibonacci benchmark from the Gilectomy project. The benchmark's pretty simple. There's a function fib that calculates the nth Fibonacci number, and it's called concurrently for multiple threads. The Fibonacci calculation is deliberately slow. It's mostly there to do some work. I was running the program with an early version of no-GIL Python with 8 threads, and I was pretty happy to see the top command show all 8 cores being fully utilized. If you graph the performance results, they look something like this, and I was ready to call it a day. And indeed, this would have been great if the chart showed throughput versus the number of threads, but the y-axis here is actually time taken. Even though the program was using 8 CPU cores, those cores were being used so inefficiently that there wasn't a speed up. In fact, adding more threads made things worse. Here's the same data, but inverted to show throughput instead of time taken. If things were going well, then 8 threads would be 8 times faster than a single thread. But here, 8 threads are actually only running at 25% of the speed of a single thread. So what's going on? It's the same issue I mentioned previously. Reference count contention here is so bad that the program didn't scale at all. And in this case, reference count contention wasn't solved by immortal objects. Let's look at the Python bytecode. I've highlighted the 2 load global bytecode operations. These correspond to the 2 recursive calls to fib. They load the fib function from the globals dictionary and push it to the interpreter stack. As part of that operation, they increment the reference count of the fib function object. Later, when the function call is finished, the object is popped from the stack and the reference count is decremented. Since all the threads are calling the same function, they're also all concurrently modifying that same reference count field on the fib function object. We could try making all functions immortal, but that has a number of downsides. Functions don't necessarily live forever. In addition, they hold a reference to the globals dictionary, so making functions immortal would prevent the globals dictionary from being freed, which would in turn hold on to global variables unless those variables were explicitly deleted. Some programs and libraries depend on running finalizers for global variables at exit, and making function objects immortal would prevent that from happening due to the reference chain from function objects to the globals dictionary to global variables. This project uses a variant of deferred reference counting to address the reference count contention on function objects. Deferred reference counting skips the reference counting operation for objects as they're pushed to and pop from the interpreter stack. Other operations like assignment to a dictionary list use the normal reference counting behavior. Because we've skipped some reference counting operations, we can't free these objects when their reference count reaches 0. Instead, they're only free during the cyclic garbage collection. The garbage collector is modified to inspect the interpreter stack. At the start of a garbage collection cycle, it looks through all the objects on the interpreter stack, adds back any missing references. That's the deferred part of deferred reference counting. It then does a normal garbage collection cycle and finally removes the reference count that it added in the first step. So deferred reference counting avoids some reference counting operations, but it also delays deallocation. Normally that could cause problems, but we only enable deferred reference counting for some types of objects: module level functions, methods, and some type objects. It turns out these objects would typically only be deallocated during a cyclic garbage collection cycle anyways. I mentioned before that function objects have a reference to the globals dictionary. Well, the globals dictionary also has a reference to functions defined at the module level. Functions in Python naturally form reference cycles, and there are similar reference cycles for methods and type objects. So deferred reference counting on these objects doesn't typically delay deallocation compared to the normal behavior in CPython. Here's the Fibonacci benchmark again, but with deferred reference counting enabled. The results are much better now, and we get a nearly 8 times speedup with 8 threads. The NoGIL project uses a combination of these reference counting techniques to achieve good single-threaded performance and avoid a lot of the obstacles to multi-core scaling. Most objects in NoGIL Python use biased reference counting. They are deallocated immediately when their reference count goes to 0, with a few exceptions. A few types of objects, such as function objects, methods, and some type objects, use deferred reference counting within the interpreter loop. Outside the interpreter loop, they're treated like other objects and use biased reference counting. They're only deallocated during garbage collection cycles. Constants, such as true, false, and none, are immortal. Reference counting on these objects is skipped everywhere, both in the interpreter and in library code. They're never deallocated, at least not until the interpreter shuts down. Now that I've talked about reference counting techniques, I'd like to move on to collection thread safety. This is how things like dictionaries, lists, and sets handle concurrent accesses. Dictionaries are particularly important because they're widely used in Python, including for storing object attributes and global variables. Like many previous attempts at removing the GIL, the NoGIL project adds per-instance locks to collections like dictionary and list. I'm going to talk a bit about the locks used. The implementation is based on the locks used in WebKit, the browser engine for Safari. The design and trade-offs are described in detail by Phil Peaslow in a blog post called Locking in WebKit. If you're interested in how locks work, I highly recommend it. It's one of my favorite technical blog posts, and if you search Locking in WebKit, it'll be the first hit. I'm not going to describe the implementation too much, but I'll describe some of the more important attributes of it. First, the locks are small. They can be as small as 2 bits, but due to alignment requirements in C, in NoGIL Python, they typically require the same space as a pointer, so 8 bytes in a 64-bit system. That's still a lot smaller than pthread mutex or C++11 standard mutex, which take 40 or more bytes. The locks also only need to be initialized to 0, just like an integer. It doesn't require any memory allocation. It has fast, uncontented access. That's really important because by far, the most common case is that only one thread accesses a given collection at a time. Finally, it avoids thread starvation in heavily contented locks by eventually handing off the ownership of the lock to the threads in the same order that they attempt to acquire it. All right, that's it about the locks themselves. One of the challenges with introducing locks to collection types is that you have to be careful to avoid introducing lock ordering deadlocks. For example, storing a key in some dictionary might involve comparing that key to an existing key already in the dictionary, comparing it for equality in particular. For string keys, that comparison's really simple, but user-defined types can override the equality operator. And if that user's code accesses either this dictionary or some other dictionary while implementing equality, then we risk deadlock by holding multiple locks while another thread might attempt to acquire those same locks in a different order. For dictionaries, a reasonable solution is to unlock the dictionary before calling the equality operator and relock it afterwards. Essentially, we make sure that a thread can hold the lock for only a single collection at any time. And that's what was implemented in this in this project for a while. Excuse me. But it turns out there's a lot of places you might want to call back that might call back into Python and incidentally acquire locks. For example, the PyDecref macro can call arbitrary code through an object's finalizer. Identifying all these places is doable, excuse me, but it's tedious and error-prone. It'd be really convenient if we didn't have to be so careful about unlocking these locks before calling back into Python or calling things like PyDecref. Notably, the global interpreter lock doesn't have this issue. You just need to acquire the global interpreter lock once, and it's only released in a few places, usually implicitly. For the most part, you don't have to worry about lock ordering deadlocks with the global interpreter lock. Fortunately, we can make these locks behave more like the GIL. The basic idea is to allow threads to implicitly release locked collections in places where the threads would have normally released the GIL. We don't do this for all types of locks, but instead introduce a new internal API, PyBegin critical section and PyEnd critical section. PyBegin critical section locks the past in lock and then pushes it to a stack of active critical sections for the current thread. Subsequent calls to PyBegin critical section also push onto that same stack. When the threads would have normally released the GIL, the threads instead release all the locks for the active critical sections and then mark those sections as inactive. This includes times when the thread is blocked trying to acquire a lock held by a different thread. In places where the thread would have normally reacquired the GIL, it reactivates the topmost critical section and locks the corresponding lock. However, it doesn't lock any previous critical sections. The PyEnd critical section releases the lock for the topmost section and pops it from the stack. If there was a previous critical section and it was inactivated, it's now reactivated and its lock is relocked. The final PyEnd critical section unlocks and removes the last critical section from the stack. The scheme avoids the risk of any lock ordering deadlocks. To understand why, consider that a lock ordering deadlock requires a thread to hold one lock, let's call it A, and be blocked while trying to acquire a second lock, say B. There also has to be another thread trying to acquire those same locks, but in a different order. With this API, the moment a thread is trying to acquire that second lock, B, it will release its previously held locks, allowing other threads to proceed and avoiding the deadlock. So since this avoids lock ordering deadlocks, why isn't something like this more widely used? Well, with this sort of scheme, there's a lot of places where the held locks might be implicitly released. And that's not something you really want in a general locking API. But it's fine here for replacing the global interpreter lock because the places where these locks might have been implicitly released are the exact same places where the GIL could have been implicitly released. There's one additional bit to the critical section API. Sometimes it's useful to lock two collections at once. For example, when extending a list with the items of a dictionary, it's useful to lock both the list and the dictionary. The list because it's being modified, and the dictionary so that the extend operation sees a consistent view of the items in the dictionary. So there's one additional API that locks two mutexes at once. Locking collections works well for most accesses, but there's a few operations where acquiring a lock would inhibit scaling. The most important is when accessing a single item in a dictionary, because things like globals and object attributes are implemented using dictionaries, and a single dictionary may be frequently accessed by many threads, just like we saw in the Fibonacci example. The single element accesses for list and dictionary are implemented without acquiring the collection's lock. This is made more complicated by reference counting. The accessing thread needs to increment the reference count of the returned object, but another thread might have simultaneously modified the dictionary and freed that object. To handle this, the fast lockless path only handles the case where the reference count isn't 0 and where the value is still in the collection. If it fails, the operation falls back to a slower path that retries the operation after acquiring the collection's lock. Normally, this scheme wouldn't be safe because when an object is freed, its memory, including the reference count field, is invalid. The scheme requires cooperation with the memory allocator to ensure that the reference count field remains valid for the duration of this access, even if the object's freed. That leads us to the memory allocator. Python has a memory allocator called pymalloc. It's optimized for small allocations, and it's used for allocating Python objects. Unfortunately, it's not thread safe. This project replaces pymalloc with memalloc, a memory allocator written by Don Leyen at Microsoft Research. Memalloc's performance is slightly better than pymalloc, and it's thread safe, so it's likely that memalloc will end up in Python independent of any GIL changes. And there's an outstanding PR from Christian Himes that implements memalloc into CPython. Memalloc, with some modifications, is also important for the lockless dictionary and list accesses we just talked about. Finally, memalloc makes it easier to make Python's cyclic garbage collector thread safe. I'm going to describe how the garbage collector works in Python today, and then describe the modifications made when removing the GIL, and how using memalloc helps. The first challenge with cyclic garbage collection is that the mechanism used to keep track of objects isn't thread safe. The current garbage collector relies on a global linked list to find all Python objects that support cyclic garbage collection. The linked list uses two fields in the object's headers, gcnext and gcprevious. Objects are inserted into the linked list shortly after they're allocated and removed from the linked list before they're deallocated. This poses a thread safety issue because threads allocate and free objects concurrently. The list also can't be made thread local because objects might be allocated on one thread and deallocated on a different thread. This project gets rid of the doubly linked list, although the gcnext and gcprevious fields are still in use for now. Instead of the linked list, the garbage collector uses memalloc to find all the objects that support garbage collection. These objects are allocated from a separate memalloc heap than other data. The collector scans each block in the heap to find objects. Unallocated blocks and objects that aren't tracked by the collector have their least significant bit in the first word set to 0. Tracked objects have the least significant bit set to 1. The cyclic garbage collector can't run safely when other threads are accessing or modifying Python objects. The global interpreter lock previously ensured this, but now the collector needs to pause all other Python threads before running. Python already had a mechanism for requesting threads to handle asynchronous signals and exceptions, which we've extended to handle requests to pause for the garbage collector. Once all other Python threads are paused, the garbage collector runs. The other threads are resumed after the collector finishes identifying unreachable objects. I want to talk a bit about compatibility because a frequent concern with removing the GIL is that it will break existing Python code in extensions. For pure Python code, that is, Python code that doesn't make use of the C API, I don't expect the code to require any changes. Now, that probably won't be 100% true, but I think it's pretty close to it. Importantly, things that looked atomic with the GIL, like list.append, still look like they're performed atomically due to per-collection locking. For C API extensions, many don't require any changes, and those that do, the changes are pretty small. I'll talk about a few examples later. The most common issue is global or shared data in C that's implicitly protected by the GIL. A less common issue is due to the use of borrowed references. For example, PyDictGetItem and PyListGetItem return objects without increasing their reference counts. This can cause problems if the dictionary or list is concurrently modified. Most uses of borrowed references aren't an issue. For example, PyDictGetItem is frequently used to parse the keyword arguments dictionary, and that dictionary is effectively private to the called function. It's not shared with other threads. I'd like to give some examples from real Python packages that use the C API. scikit-learn is a Python library for machine learning that builds on top of NumPy and SciPy. Under the hood, it's a mix of Python, Cython, and some C++. Thanks in large part to Olivier Grissel, scikit-learn now works without the GIL, and there's even a continuous build that runs with no GIL Python. I want to go over the bugs we fixed while making scikit-learn work without the GIL. Getting all the scikit-learn tests to pass required fixing 10 issues. Of these, 5 were in the no-GIL project, but unrelated to removing the GIL. The other 5 issues were related to removing the GIL, essentially thread safety issues in these projects if you ran them without the global interpreter lock. One of these issues was in the scikit-learn code base directly. 3 of them were in dependencies, 2 in NumPy and 1 in Python, and the last one was in VizTracer, which isn't really a dependency but a useful profiling tool. Here's the bug in scikit-learn caused by removing the GIL. This is an excerpt of some Python code used to compute k-means. When run without the GIL and with OpenMP parallelism enabled, the operation would give an incorrect result, triggering test failures. The problem is that Python's with GIL construct won't prevent multiple threads from running at the same time if you've already disabled the GIL. The fix was pretty simple. We just replaced with GIL with a different lock. Since the code is already using OpenMP, we use an OpenMP-based lock. The actual PR that landed in scikit-learn is a bit larger than this because the same pattern is repeated a few times in the file, but this is the essence of the fix. I'll only briefly go over the other issues that cropped up when removing the GIL. For NumPy, there were 4 total issues, but 2 of those were fixed before the scikit-learn effort. Of the 4 issues, 3 were issues due to caches that were no longer thread safe without the GIL. Some of those caches could just be disabled when running with no GIL Python, but one of the caches had to be protected by a lock. One issue was due to the use of borrowed references in NumPy that was no longer safe without the GIL. That was fixed by switching to an API that returned a new reference instead. Python had an issue with locks allocated from a pool that wasn't thread safe without the GIL. But it turned out those locks weren't needed if atomic operations were available. Finally, VizTracer, the profiling tool, had some internal state in C that needed to be protected by a lock. The critical section API came in handy there. The fixes for scikit-learn and VizTracer have landed upstream in those projects, but the changes to NumPy and Python are still in forks maintained by me. Overall, the changes were relatively small. The scikit-learn test depended on a total of 25 other Python packages. Other than the changes I mentioned here, those dependencies didn't require any other changes. The other project I'd like to talk about is work done by my colleagues at Meta AI on Hanabi. Hanabi is a card game that's been proposed as a benchmark problem in AI. Hanabi is an interesting AI challenge for a few reasons. First, it's a cooperative game. 2 to 5 players work together to place down cards in numerical order. It's also an imperfect information game. You can see other players' cards, but you can't see your own cards. And to play well, you need to think about your partner's behaviors and how they'll respond to your actions and the limited information that you're allowed to share. My colleagues have developed agents, bots, that play Hanabi, both with other bots and with people. The bots use artificial neural networks to decide what actions to take, and they're trained using reinforcement learning techniques. The code is partly in Python, using PyTorch and NumPy, and partly in C++, using PyBind 11. Here's a diagram of the system used to train the bot. The system simulates thousands of games, that's the section marked environments, at once using multiple threads. Each thread is responsible for simulating more than one game. The inference model and the training model are the bot's neural networks. The inference model determines what action the bot will take in the simulated games. The results of those simulated games are fed into the training model to improve the bot's behaviors. Every so often, the training model is copied back to the inference model. The Hanabi system was built with vanilla Python and with the global interpreter lock in mind. The worker threads and inference loops have to avoid running Python code. Only the training loop and the training model run the Python interpreter. This means that many pieces of code had to be written in C++, or like the inference model, written in a subset of Python called TorchScript that's serialized to representation that can be executed from C++ without invoking the Python interpreter. Having so many components in C++ made it harder to explore new research ideas. My colleague Hengyan implemented a version of the system designed for running without the GIL. Most of the components were moved to Python, including the worker threads, the inference model, and the logic for each player. The environment, that's the component that implemented the rules of the game, stayed in C++ because there isn't a compelling reason to move it to Python. The research ideas don't involve changing the rules of Hanabi. As I mentioned before, the project uses NumPy, PyTorch, and PyBind 11. Those projects were already patched to work without the GIL, although we found and fixed another issue with the PyBind 11 patch in the course of this work. I'd like to show the performance of this system and the steps we took to optimize it. First, here's a chart showing the performance of the new mostly Python system with the global interpreter lock. The x-axis shows the number of worker threads, and the y-axis shows the number of games simulated per second. The GIL is pretty clearly a bottleneck here. Using more than one worker thread doesn't improve performance. Here's the performance once the GIL is removed. Now adding more worker threads improves performance at least up to a bit. This only shows up to 8 threads, but the computer it's running on has 40 hardware cores. This is the same system, no GIL, but with even more worker threads, up to 80 instead of only up to 8. We hit a bottleneck pretty quickly. Increasing the number of worker threads beyond 10 didn't improve performance. Running with more worker threads actually hurt performance. To investigate this, I used Linux perf tools and GDB. Perf top showed that the majority of CPU time was spent trying to acquire a lock, but didn't give much information beyond that. GDB narrowed the issue further. At any given point, most of the threads were stuck trying to acquire the same lock. This is a lock I added to our patched version of PyBind 11 to make it thread safe. PyBind maintains an internal hash table called registered instances that maps C++ pointers to their corresponding Python wrappers. This is done so that if you return the same C++ object multiple times, you always get back the same Python wrapper object. The lock I added to protect the hash table was the source of the bottleneck. There are a lot of techniques for implementing concurrent hash tables, but one of the simplest is to split the table into multiple pieces, each a hash table with its own lock. The key, in this case the C++ pointer, is used both to determine which sub-hash table to use and to index into it. This worked surprisingly well and was easy to implement. The turquoise bars show the performance after splitting up the registered instances table. This new system can simulate nearly 1,200 games per second with 60 workers, which is about a 20 times speedup compared to if we ran this program with the global interpreter lock enabled. I suspect there are still opportunities to further improve scaling, but we think this system has performance comparable to the original C++ heavy system. And having more of the components in Python made it much easier to explore new research ideas. You can try out the no-GIL version of Python yourself. Both URLs here go to the same GitHub page. The easiest way to install it is with Pyenv, a Python version management tool for Linux and Mac. There's also a Docker image, or you can build no-GIL Python from source if you prefer. You can pip install most packages, including many scientific computing libraries. Please let me know if something doesn't work by filing an issue on the project's GitHub page. In the next month or so, I'll be working on a Python enhancement proposal, or PEP, proposing to remove the global interpreter lock from a future version of Python using the ideas from this project. To help address compatibility issues, I'll propose placing the GIL changes behind a compiler flag so that the default build will still have the GIL enabled. I expect this to take some time, but in the meantime, I'd appreciate your feedback on the project, either on GitHub or elsewhere. And if you're interested in efficient multi-threaded Python programs, please try out no-GIL Python. Thank you.
All right, we have time for a couple of questions. I've been asked to ask a couple of questions first. So, Sam, you didn't know this was going to happen, did you? My experience in working on the galectomy, I had a miserable time debugging because debugging across multiple threads makes it so hard to go back and reason about who changed what and how it happened. I relied very heavily on what's called reversible debuggers. What has been your experience with debugging CPython and figuring out what happened?
Yeah, so that was actually one of the things I took from your project. So I didn't use the same reversible debugger. I used RR, which is a project from Mozilla, which is another reversible debugger. And it made debugging both thread safety issues and reference counting bugs much easier because you could go to the source of the failure and then just go back in time to figure out what operation was responsible for corrupting the data.
Okay. If people have questions, by the way, you can line up at that mic, and I might call on you. So you talked about how your I can't remember, there's 5 or 6 different, like X reference counting and Y reference counting. The one where you're, the bias reference counting, that's that has the per thread local count and then the global count. So one of my first experiments with the Galactomy was to just switch to atomic reference counting for everywhere. And performance was tragic. And in particular, the really tragic thing was that the more threads you added, the slower it got. And I'm not good at computer architecture, but my understanding is that essentially the way that atomic Inker and Decker works is that there is an internal bus that's shared by the cores on your CPU that they use to talk to each other, to tell each other things. And in particular, when you do atomic Inker and Decker, it's like there's one CPU telling the other CPUs, hey, forget about this cache line because I've blown it away, because I did a write to that. And the more Inkers and Deckers that you do atomic, the more contention there is for that bus. And so that's a place where you're going to have scaling issues where like atomic Inker and Decker is going to fail you. So how much overhead did you find? Like you talked about a certain amount of overhead. Like did you see problems with this contention where adding threads made the atomic Inker and Deckers get worse because you were doing enough of them?
So my understanding of the way caches work now is that there isn't a global bus lock. I think that was the early implementation on multiple, when there were multiple
Not a bus lock,
processors.
but a bus where they have to communicate with each other and they have to, well, I guess a lock, yeah, okay.
So caches are confusing. I'm pretty sure if I say something, it's going to be at least a little bit wrong, maybe a lot wrong. But so atomic increments and decrements don't do a global lock anymore. They effectively lock the cache line. What that actually means and how it's implemented in hardware is a little bit complicated, and I don't think I can explain it. But what it means is that atomic increments and decrements to different cache lines still scale well. So that's only kind of relevant to the reference counting here. It means that if you have a bunch of threads and they do some atomic reference counting, it still works fine as long as they're not to the same object. But biased reference counting doesn't really address the scalability issue. It only addresses sort of the single-threaded overhead. And the way scalability is addressed is by avoiding contention, reference counting contention on shared objects. So mostly skipping the reference counting, either by deferred reference counting for functions or immortal objects, or skipping the reference counting entirely for immortal objects. There are some objects that are going to be shared across threads, and they're going to have multiple threads modify the reference count. And that's often okay. It's sort of a matter of scale. Like reference counting is just incredibly frequent, so doing it everywhere doesn't scale at all, but doing a little bit is okay. Like having some objects that are shared is still fine. And that's what we saw in the Hanabi system, is that there's a bunch of Python objects that are shared between the threads, and it didn't affect performance too much. It was only the few things that were accessed so frequently, like the dictionary lock or the function objects, that really affected scaling.
Okay, that's heartwarming. We do have a question from the audience.
Thank you for the amazing talk. I just wanted to understand, do you think in the future we will be able to get some semantics behind the whole work of parallelizing Python, removing the GIL? Because, of course, removing the GIL is going to introduce some edge cases in a lot of stuff. Do you think we'll be able to have formal guarantees on what we have in the Python code, more or less, or a model or a proxy? Especially because you've shown a lot of research ideas like biased reverse counting, so it looks like it's possible.
So I think one thing that would be nice is to have a formal model of what operations are performed atomically. But I don't think that's practical because I think it would be hard to come up with a formal model of how things behave currently in Python. And keeping existing behavior, I think, is more important than formalizing the model. One of the challenges with both the way the current implementation works and no-GIL works is that there are a bunch of operations that are seemingly atomic if they're performed on simple types, but might not be atomic if they're performed on types that override equality or some other function. And it's really hard to reason about that in general. So I think what will be necessary is sufficient documentation, but I think a formal model will be pretty difficult.
And also, if I can ask another question, have you considered lock-free data structures for some structures in Python?
So I think lock-free data structures might make sense in some places. I rejected lock-free data structures for things like the built-in dictionary type because in general the lock-free algorithms are slower to execute for, at least for like single-thread cases, than algorithms that use locking. And the most common case here is lots of threads, or threads accessing individual objects without any contention.
Thank you very much.
Yep, next question, please.
Hi, thank you for the talk. You mentioned the critical section technique and that it works because of the current design with the GIL. Once it's removed, is there anything we need to do like for further maintenance to make sure that nothing breaks?
Yeah, that's a great question. So one thing I didn't mention in this talk is that the APIs that currently exist to acquire or release the GIL, like PyBegin allow threads, I think, and PyEnd allow threads, are still used and are still important in this project. The good thing is that means existing code continues to work, but it can be a little bit confusing, and it was one of the things that came up in the Hanabi project, is that my colleague wrote code not using this, and it ended up causing issues. Essentially, you still have to use those macros at places before the thread would block. And it's important for two reasons. One is like the critical section API, and the second is to allow the threads to pause at the correct place for garbage collection. If you don't use that, if you skip over that and block while, I guess, still attach the Python interpreter, you can risk introducing deadlock. In the same way that if you block a thread while holding the GIL, you can risk causing deadlock. So they're still necessary, but they're used in exactly the same places.
Right. Thank you.
Okay, one more from the audience.
Thank you. I loved this work, so thank you so much. So I have a question more about the community and the process. So you're in the process of submitting this as an upstream patch to the core CPython interpreter, and I know that you have been in conversations with people from the core Python development community, and the same way that in previous attempts they say, no, the 60% slowdown is too much. I'm guessing you have some guesses of what do you need to achieve before saying, okay, this is ready. Do you have some information about, yeah, these are the goals that have been reached and the ones that I still have to do more work to reach before the community accepts this?
Yeah, that's a great question. In terms of sort of what's acceptable performance, I don't know. I think it's something we'll sort of have to figure out. But to answer the question is, no, I don't know.
Okay. And other things beyond performance, like impact on other libraries or stuff like that?
So, I mean, having low impact on other libraries is clearly important. But again, it's one of those things where it's much harder. Performance itself is kind of hard to quantify, but impact is even harder. So I think it's going to be hard to know what the requirements there are.
They'll know when they know it, so I guess.
Yeah, so, yeah.
All right, I'm going to take my session chair privilege. I'm going to ask one more question before I let you go. Sam, you get to borrow somebody's magic wand for 10 minutes. If you could, would you give up on reference counting in Python and actually go to tracing GC? Because as we saw from your slides, you've had a very complicated and difficult trail to get to where you are with performance. So reference counting is now very complicated and it's still causing performance issues. My understanding is that tracing garbage collection in a multi-threaded system is just fundamentally more multi-threaded friendly. So would you prefer, if you could change Python history, would you go to tracing garbage collection if you could?
So the short answer is no, I wouldn't. And well, this is a tough question. So I think the typical answer would be yes. Like it's much easier to get better scaling. There's a lot of issues you can avoid. Wouldn't have been great if we had gone to cyclic garbage collection. But one thing I really like about reference counting in Python is that it means that destructors are called as soon as the reference count goes to 0. Essentially, as soon as the object is no longer referenced, as long as there's no cycle, which is the common case. And I found that this makes it much easier to integrate some C++ APIs, especially ones that handle external resources, either lots of memory on the CPU or GPU memory. Before working on this, I worked on PyTorch, and before that, Torch 7, which was written in Lua. And Lua has a cyclic garbage collector. It doesn't use reference counting. And we ran into issues pretty frequently due to the garbage collector. So switching to Python and reference counting was actually really nice in the process as we were going from Torch to PyTorch. So I like reference counting. I feel like that might be a little controversial, but yeah, I'd keep it.
It's good news and bad news for PyPy.
Yeah.
All right, thank you, ladies and gentlemen. It's coffee time now, so go get your caffeine on.
Very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Okay, ready? Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Okay, ready? Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython is, well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Okay, so good morning and welcome back. We hope you enjoyed the keynote. It's full of cool ideas there for performance, which is always nice. But the day is only beginning, and now we have here with us Luciano Ramalho. Luciano is the author of Fluent Python. It's a Python book published in 9 languages. He's a principal consultant at ThoughtWorks and also a fellow of the Python Software Foundation. Luciano is here to present typing.protocol, type hints as Guido intended. Welcome, and the floor is yours.
Thank you very much. I think this is the fanciest auditorium that I've ever spoken to. I'm hoping to be up to the task. So, typing protocol, type hints as Guido intended. The title of the talk is a reference to this T-shirt, which I wish I had, but I don't, right? Programming the way Guido indented it. So yeah, that's my book. Almost everything that I'm going to show you today came out of a lot of research that I did while writing the book. The second edition has more than 100 pages about type hints and other new stuff. So we're going to talk about 4 things. What is a type? The 4 modes of typing, some typing protocol examples, and a conclusion. Okay? So, what is a type? So this is a direct quote from PEP 483, the theory of type hints, which was written by Guido van Rossum and Ivan Levkivsky. So there are many definitions of the concept of type in the literature. Here we assume that type is a set of values and a set of functions that one can apply to those values, right? For me, my first understanding of types was very much focused on the set of values, because you think about, oh, okay, so you have this set of the complex numbers, and then you have the real numbers, and then you have the integers, and so on. But that's in the beautiful, pure world of mathematics. In the real world, there are some small issues, right? Reality is complicated. Reality is more complicated than math. So I have an integer, and then I convert it to a float. Looks all right, except that one is not equal to the other. Right? Actually, in the set of floats, there is no float that represents precisely that number. And if you import the decimal module, it can, when you create an instance of decimal, it shows you then a string representation with full precision. And as you can see, they are not really the same number, although they are pretty close, right? So, yeah. A little side note, it's interesting that the float type has been around for a long time. It's basically embedded in all modern CPUs, right? All the basic operations with floats are embedded in the CPUs. But it's a type that is more useful to scientists and engineers than for people, for instance, who deal with money, right? Which is, I guess, most of us, or many of us, I don't know. So I always thought it was kind of weird that most mainstream languages don't have a really good way of representing money. And people try to use float for that, but it's not great. So decimal is an alternative in Python to do that. But the set of values definition is not useful for other reasons also, because Python does not provide practical ways to specify types as sets of values, except for enum. In practice, in the standard library, we have very small sets, like the set of the none type, which has only one instance, none, bool, which has two instances. And then, on the other hand, you have extremely large ones with billions of instances, right? The int and the string types, for example, the possible values are only limited by the width of the pointer in the machine. And also, we have no way to say, for instance, that a quantity type that I would like to use, for instance, in an e-commerce application to validate that orders are not placed with 0 of an item, or more than 1,000. This could be an interesting safety measure, right? Usually, it's rare that you order 1,000 or more of something in a retail store. So you can't say that. There's no way in Python to say that in the type system to express that, right? For instance, also there's no way to say that our airport code is the set of all the 17,576 three-letter combinations of uppercase ASCII letters. Neither of those sets can be expressed in the type systems. At least not in the type systems of mainstream languages, and certainly not in the type system of Python. So, in practice, it's more useful to think that int is a subtype of float because it implements the same interface. Basically, the interface of float has to do with arithmetic, and all the operations also apply to integers, right? But ints also have a few other methods, like, for instance, those that do bitwise manipulation, shift right, shift left, things that wouldn't make sense in a float. So that's the main reason why we can think of int as a subset of, not a subset, a subtype of float, because it implements all the types, the entire interface of float and an additional few methods. I put a couple of asterisks here because just yesterday I discovered there are a few float methods that int does not implement, okay, but they're kind of bizarre. One of them is one that generates an hexadecimal representation of the float. But anyway, as a good approximation, we can think of subtypes, and in general, that's true for subtypes, that they implement the entire interface of the supertype in addition to more methods, right? So for instance, here I continue that example by showing that the pipe operator, which is the bitwise OR, you can use it with an integer, but you cannot use it with a float, right? And another example of how it's more useful to think about the interface is that in Python's static type system, we have now the any type. And basically, because any value can be assigned to an object variable, and any value can be assigned to an any variable, you can say that they are like the universe types, right? But the super important difference between them is that the object type implements a narrow interface, right? Pretty much most subclasses that we create from object add methods, right, that don't exist in object. But any, on the other hand, is this magical type that is required because of the nature of the gradual type system that we have, which means that sometimes you may have a piece of code that is not annotated, or you're using a library, a third-party library that is not annotated, so you get a result from there, and all that the type checker can infer is that the return is any, right? And any satisfies every interface. It's like this magical interface that contains all possible methods that exist today or that will ever exist, right? So this is a crucial difference between them. So in general, if you think of subtypes as sets, you get the biggest set is in the top, right? Object is the set of everything. And then you go down, 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 down to more specific types, more specialized types that usually have fewer instances. But on the other hand, the interface grows, right? At the top of our class hierarchy, the interface is narrower, and as you go down, it gets wider, more specialized, and it gets more methods. So, from that definition of PEP 483, we are going to adopt that point of view that a set is a set of functions that one can apply to those values. A set is defined by the set of functions that you can apply to an object. Right? And then here's another quote from Smalltalk. And I'm not talking about Smalltalk just because I have a gray beard. I'm talking about Smalltalk because it's really the type system of Smalltalk is very similar to the type system of Python. Just like the type system of Ruby and the type system of JavaScript. And in the Smalltalk community, they use this term protocol, right? So this quote is from one of the designers of Smalltalk. Every object in Smalltalk, even a lowly integer, has a set of messages, a protocol, that defines the explicit communication to which that object can respond. In Smalltalk, there was no explicit way to declare a protocol, but some browsers that you use to code in Smalltalk did present clusters of methods as a protocol. And of course, a class could implement several protocols. So that was the way they used it, more as metadata for the programmer than something that was checked, right? So the main takeaways from this first part is that types are defined by interfaces, and protocol is a synonym for interface, right? So that's where the name the name of the typing protocol class that we're going to talk about comes from. Now let's talk about duck typing. So last time I looked, Alex Martelli, who is my friend and also one of the reviewers of the first edition of my book, was credited by Wikipedia for being the first person who used in a written message that you can find online, this duck metaphor. I don't know if he invented it, but he was the first one who used it in a Python mailing list to talk about, to respond to a question about polymorphism that had to do with type checking in Python, many years ago when there was no static typing, right? So the idea is that you don't check whether something is a duck. You check whether it quacks like a duck or walks like a duck, etc., depending on exactly what subset of duck-like behavior you need, right? I started using Python in '98, and at the time there was no ABCs. There were no ABCs in the standard library. So in the beginning, I was a little bit mystified by the appearance of phrases like, oh, this function takes a file-like object. Okay, what is that? There was no definition anywhere, right? But it was a common practice to have these kinds of expressions. I think there's still phrases like that in the documentation. A buffer-like object is another thing that is super important for data science. Then there was some formalization of what that means, but the interesting thing is the precise meaning of a file-like object depended on the context, right? Sometimes all you needed was, I need something that has a read method that returns bytes, for instance. That's file-like enough for me in this moment. Does that make sense? In another situation, maybe you need something that has a close method or a write method, things like that, right? But it was always very, very informal, similar to how it was informal in Smalltalk as well. So one definition that you can give if somebody asks you what's the difference between a protocol and an interface, if we are not talking about static typing, you can say that protocols traditionally were informal interfaces that were not defined explicitly in code, but where the code depended on one of those interfaces, or on a few methods to do something, right? So, for instance, when I've taught Python to lots of people, and most of my students over time came from statically typed languages like Java mostly, and C++, C#. And so I always like to show them this example of a very simple function, double, to illustrate duck typing, right? So I create this single function, double, and I can use it with an int, with a float, with a complex, with fractions, and those are all numbers, but I can also use it with sequences, right? So what is the idea here? What is the protocol that double expects X to fulfill? Double expects that the argument X is able to multiply itself by an integer. That's what is implicit in that code, and this is why all of those objects support that, because under the covers they implement a method called dunderMul, right? So dunder, double underscore in front, behind, and some special name. dunderMul is actually the method that any class that you write can implement to support the multiplication sign, this operator, right? Now, here's another example, a more dramatic example. So I have this simple class that represents a train, okay? And its only attribute is a length that is established when it's constructed. And so then we have the dunderlen method that returns the length, and we have the dunderGetItem method. And basically it checks whether the I is within the range, right, from 0 to length -1. And if it is, then it returns a string saying car number such and such, right? Otherwise, it raises index error. So for instance, if I build a train with 3 cars, and I ask the len of the train, I get 3. So this is duck typing, right? Notice this class inherits implicitly from objects. There's no other special class that I'm using here. So what makes something work with len in Python is basically, for built-ins, Python has a shortcut, okay? Built-in and extensions, like extensions written in C or Rust or other languages, can implement in those lower level, using the Python C API, what is called a slot that will respond to the len. But even if you don't do that, there is also, some, it's funny because the C code of Python is kind of object-oriented C, okay? Not C++, object-oriented C. There's this kind of a nested structures in which everything that has a len, everything that has multiple items in it, has a field that Python can inspect immediately to know how many items there are. Okay? So that's very fast because it doesn't involve any method call. But if that field doesn't exist, then Python will try and find whether there is a dunderlen implementation either in the low-level language or in Python if it's a Python object, right? So that's how len works. And it's an example of duck typing, right? You don't need to inherit from anything to implement, to support len. You just implement that method. The second example is what triggers the dunderGetItem method, right? And again, another example of duck typing. But the third example is really dramatic because the target of a for loop, in this case the T, is supposed to implement an interface of iterable, right? And how do you implement the interface of iterable? Formally, you implement a dunderIter method that returns an iterator, which is another interface that implements a dunderNext method. However, I didn't implement dunderIter here. Okay? Well, anyway, in a regular duck-typed language, you would any class that would implement dunderIter would work for iteration. But Python goes even further than that because that's so fundamental. Iteration is so fundamental to the language and also to support legacy code. It just so happens that the Python machinery, this is actually built in the iter built-in function. The iter built-in function looks to see if the object implements dunderIter, but if it doesn't, then there's a fallback, and the fallback is, does it implement dunderGetItem? And then it tries to send a 0, it tries to call dunderGetItem with a 0 argument. And if that works, then it starts iterating by providing more indexes until the dunderGetItem returns index error, right? So this is kind of an extreme example of duck typing, right? Of the machinery of the language trying to use the object, even when the object doesn't implement one particular interface, it falls back to another interface and does what you expect, right? Okay, so now I'm going to show the first example of a protocol. And this, I think, is the best example of a protocol in the whole talk. It's the most similar to the kinds of protocols that you are likely to use in your job. So what I'm saying here is I have a function called run file, and it takes one argument called source file, which is a text reader. And then immediately above, there's a definition, right, of a class that inherits from protocol, right? And that definition is exactly like I wrote it here. The ellipsis in line 203 is part of the syntax, okay? The ellipsis is telling you that the body is omitted. Instead of pass, which explicitly says this doesn't do anything, what this is saying is the body will be defined somewhere else. It doesn't matter what the body is. So in order to satisfy that protocol, an object, any object in the world can satisfy that protocol by implementing a read method that returns a string. That's it. Okay? So, and often you will see code like that, where the interface is defined right above the place where it's used. This is common. We see that a lot in Go code. And why am I talking about Go code? Because Go is the first mainstream language that is statically typed, but also supports this idea of declaring protocols. Notice that whatever class I use to produce a text reader doesn't need to inherit, and in fact, they won't inherit from text reader. All they have to do is to implement the interface, okay? So, the benefits of using typing protocol are that you can preserve the flexibility of duck typing, so you can let your clients know what is the minimal interface expected regardless of class hierarchies. You can support static analysis, right? IDEs and linters can verify that an actual argument that appears in a call site for that run file function does satisfy the protocol, right? And you reduce coupling because the client classes don't need to subclass anything, just implement the protocol. And this also makes testing easier, right? Because if you need to create some kind of mock to test, all you have to do is implement that one method. You don't need to inherit from anything, right? So let's talk about the 4 modes of typing. We all know there's this duality between static typing and dynamic typing. And this has to do with when the types are checked, right? Static typing is designed to support static checking, which is checking done by tools and compilers and so on. And runtime checking is, dynamic typing was invented to support runtime checking, right? The authors of the type hints PEP promise that Python will remain dynamically typed, okay? But actually, the situation is more interesting than this. The situation is that we have these 2 axes where, besides the static checking and runtime checking, we also have the issue of how the types are defined or identified. So in static typing of languages like Java, you have nominal types. Things belong to a type because it's explicitly declared. You inherit from something or you implement an interface, right? But with duck typing, what we have is structural types, which means objects belong to a type because they implement a certain interface. But they don't need to explicitly declare anywhere that they do implement. They just have to actually implement it, right? So these are like the 2 opposites. But this diagram actually has other areas this area, Alex Martelli, when he was reviewing the first edition of my book, he invented this term goose typing. I don't have time to talk about that, but basically that's the use of ABCs to do explicit type checks at runtime. And then Lucas Langa and others, Lucas is speaking right now at another room here, they proposed PEP 544, which implements structural duck typing or the idea of, structural subtyping or the idea of static duck typing, right? Duck typing, static duck typing. So, and that's supported by typing protocol, okay? There are other languages that support things in those quadrants. See, Go appears in the static duck typing quadrant, but also in the goose typing quadrant because it has mechanisms for type assertions at runtime, and so on. Okay, so let's see some more examples. We were talking about the double function. How could we annotate that with a protocol? So can we do that? Yeah, okay, this has a serious problem. The problem is the type checker will complain that the object type doesn't implement the move. Does that make sense? So this code, without looking at anywhere else, the type checker knows that this code is invalid. Okay? Can I use any? Yes, but it's useless because it's the same thing as no annotation. The any annotation pretty much defeats type checking. You have to use it very carefully and like an emergency exit. I could do this and say that X is a sequence of T. And here I have to introduce this idea of the type var, right? Because sequence is a generic abstract base class. So I'm saying this. If I get a sequence of floats, I'm going to return a sequence of floats. If I get a sequence of strings, I'm going to return a sequence of strings. This is what the type variable is doing, right? When the type checker analyzes this, it gets a concrete example of a call site. It looks at the type of the elements in the sequence, and then it binds T to that type, and then it will infer that the return is a sequence of that same type, okay? So this only works with sequences, it doesn't work with numbers. So the solution is to create a repeatable protocol. So the repeatable protocol is saying that it's anything that implements the under move and that takes a repeat count, which is an integer, okay? And now I can say that X is a repeatable, and this returns a repeatable. Are we done yet? No. Because now, when I call double, the result that I get is inferred to be something that only implements the under move. And if you need to do other kinds of operations with the object, you won't be able to. The type checker won't let you. Of course, at runtime, everything happens, right? Because that's the characteristic of the gradual type system of Python. At runtime, only the dynamic types exist. There's no constraint. But the type checker will point out that, if you try to do something else with this result, no, this result only supports the under move, because that's what it says. So the way to solve this is a little bit more involved. You need to create another type var. So the protocol is the same, okay? The new thing here is this type var here. And here I'm saying that RT can be bound to any type, but it has to be limited by, I don't like the keyword argument bound. I think they should have used another word for this, maybe limited or upper bound or something. But because there's the binding of the variable and the bounds, which is kind of a boundary, right? What this is saying is that RT can only accept something that is repeatable. But because of the way that this variable is declared, the actual type of it will be preserved as well. So if I pass a float, this will the type checker will be able to infer. First, it will accept the float because the float implements the mul, and it will understand that this returns a float. Okay, so that's one thing that we need to do in this case. So when I discovered these things, I was doing research for the book, and that was the time of Python 3.8 when typing protocol was introduced. There's this project called TypeShed, right, which has the type annotations for the standard library and other projects. And I contributed several fixes by implementing protocols there. So for instance, there was this bug that I found that there's the median low function in the statistics module actually works with strings, with a list of strings, okay? And there's an example just like that in the documentation. So, but it wasn't, but at the time, we had a false positive, which was that if I submitted this code to a type check, it would complain. And why is that? Because the annotation at the time was saying that the argument had to be an iterable of number. And number was a type that they invented there, which was the union of int, float, and complex, I think, or int, float, and fraction, I think. Anyway, it didn't work with strings, the annotation, although the function did work with strings, right? So the solution was to create this sortable protocol. And again, you see the same formula that we saw before, right? You have a protocol, and you have a type var, which is bound to that protocol, and then I can use that type var to say that median low accepts an iterable of sortable t, which is the type var bound to sortable, and it returns a sortable t, right? When I contribute that, I looked around and I found many other places in the Python 3.9 standard library where we could improve the annotations by using protocols, okay? And then there was the biggest challenge for me at the time was the max function. The max function is super powerful, right? Like I said, I've taught Python many times. I never saw a student say that, oh, max is super complicated to understand. No, it's pretty simple. You can pass it an iterable or a series of arguments, and then if it's an iterable, then it will return the biggest item in the iterable. If it's a series of arguments, it will return the biggest of the arguments, right? But then there is some optional arguments and so on. So it's very flexible, easy to use. I like this API, okay? But then somebody posted a bug about that, and I tried to fix it. The old type hints were like that. So overload is something that comes, this decorator comes from the typing module, and its mission is to allow you to do multiple type annotations to different ways of invoking a single function, right? So it was already pretty complicated. My time is running up, so I'm not going to delve into the details here. But this wasn't working. This was producing that bug that this person reported. The bug was that if you passed 5 and top, where top was none, it exploded. And the solution was this. It took me several hours, actually a couple of days, and with support of people more experienced than I in the type system to get to this. My first attempt had 8 overloads, then one of the maintainers of TypeShed showed me how to simplify and reduce it to only 6. Okay? In order to do that, because max is written in C, I wrote it in Python, to test and so on. And what caught my attention was that my implementation was shorter than the declarations to satisfy the type checker. Okay. So there was a lot of stuff that happened after that. If you go look at the code, it's not like that anymore. I won't go into these details here, but it's just for for you to know that with time, supports less than became supports greater than, and then they invented another name, and then they created. Now what they are using is supports rich comparison, which is a union type of supports done under LT and supports done under GT, which means that in most of those functions that appear in this list here that have to do with ordering stuff, what they do is they accept, the current annotations accept something that supports either less than or greater than. Either way, it will work, okay? There are some protocols in the standard library. Most of them have to do with numbers because, unfortunately, the numeric tower, remember the numeric tower? It's completely broken for use with typing. And why? Because the base class of the numeric tower, which is called number, has no methods, which means that objects of that class are useless. You can't do anything with them. So, but anyway, so they invented those protocols that have to do with whether something supports a conversion, right? And one of them, for instance, I use in one example in the book, which is supports index. Supports index is a particular protocol that means that the object implements dunder index, which, as opposed to dunder int, which floats also support to convert to int, dunder index is supposed to be implemented only by integral types. So, for instance, if you use NumPy, all the integral types of NumPy supports implement the dunder index method, so they can be used as indexes. Okay. So, to summarize, I recommend that you use typing protocol to build Pythonic APIs. In fact, you can say that the standard library is very Pythonic, although there are parts of it that I don't consider very Pythonic, but most of it is very Pythonic. And the standard library really cannot be annotated without the use of typing protocols, right? So you should use typing protocol because then you can support duck typing with type hints. And duck typing is the essence of Python's data model and standard library. This allows you to follow the integrate segregation principle, the I in the solid principles, which means that client code should not be forced to depend on methods that it does not use. You know, I remember when I used to code in Java, sometimes you had to implement methods just to satisfy the compiler, right? And this is a recommendation that I learned from studying Go, okay? Narrow protocols are the best, okay? Most protocols that come in the Go standard library have only one method, and that's how your protocol should do as well. That's why trying to think of an interface in terms of an ABC or a Java interface with the many methods is not a good way of getting started with designing a protocol, okay? Closing words. I have to say these things every time that I talk about Python typing, okay? Being optional is not a bug or a limitation of Python type hints. It's the feature that gives us the power to cope with the inherent complexities, annoyances, flaws, and limitations of static types. So please do not decide in your team that everything has to have type hints always, okay? That's the only way to use a type checker is in the strictest possible mode. This is really bad. It's like deciding that every code has to be 100% test covered. No, 95% is good enough a lot of times, okay? So that was my talk. Thank you so much. I don't know if we have time for questions. Maybe one question.
Yes. Thank you very much. We have time for one question. Just remember to go to the microphone so that everybody can hear it. Yes, please.
Hey, obrigado. Thank you for your talk, Luciano. Asking as a beginner in typing, I could not follow why when we define the repeatable protocol, why do we say that mul will return something that's also repeatable? Why don't I say that I'm just returning anything?
Let me see. So, the repeatable protocol, this?
Yeah, exactly. So, yeah.
So, what's the specific question?
Why am I saying that dunder mul will return t? Is it something that I decide, or is it typically the thing that makes sense?
Yes, it's something that you decide, but this is how this is how I see because the idea of this double function is that it repeats something. If it's a number, that means multiplying by 2, but if it's a sequence, it's repeating it. And that's actually why I called it repeatable and repeat count. And in both of those cases, the type will be the same. The output type will be the same as the input type. Does that make sense?
Yeah.
Actually, this is the right solution, right? Sorry. That one has that problem, and this one is the one that is correct because it uses the bound type var. Okay?
Okay, so you can catch up with Luciano during coffee break or during lunch. Thank you very much for the presentation, and let's give him a round of applause.
All right. Opa, você que começa, né? Você que vai.
Trouxe esses stickers para você.
Oh, muito obrigado.
Quando você saiu, você vai.
Muito obrigado. Olha, eu tenho 2 livros para dar para vocês.
Você vai viajar hoje?
Não.
Ok, pode.
Cool. So for our second talk this morning, so we have Laisa Uchoa. Laisa is a developer working towards a more diverse and fun Python community. She's an organizer of PyLadies Munich, and also a developer advocate for Ivan. She helps users understand databases and cool things with them. Besides Python, she likes cyberpunk, movies, tea, and human languages. Welcome, and the floor is yours.
Hello. So, good afternoon, good morning. Today we're going to be talking about Supersearch with OpenSearch and Python. My name is Laisa Uchoa. So, a little bit about me. I work for Ivan. Actually, at Ivan, we manage open source databases. And I really like Python. I worked with Python for a lot of years. I happen to live in the city of Munich, and I decided to organize PyLadies Munich chapter there. You can follow me if you want to know more about Python events. I'm always attending. So today what we're going to be talking, we're going to be talking about what is OpenSearch, why should you consider OpenSearch in your project, and I will also show you how to write some search queries in a live demo. So wish me luck, because live demos almost never work. So what is OpenSearch? If you are familiar with Elasticsearch, OpenSearch is a direct fork of Elasticsearch version 7.10. It actually has been a year, and now OpenSearch is in the version 2 already, and they do monthly releases, kind of, yeah, it's very frequently the releases for OpenSearch. If you're not familiar with Elasticsearch, OpenSearch is also okay. I'll also explain you that. So OpenSearch, as it has in the name, is open source, and is also a search engine. It has support for REST API, so if you are a backend developer or a front-end, maybe you're already familiar with it, and you don't need an extra language to deal with OpenSearch. But it does have support for many languages in Python. Python is one of the, Go, PHP, and Java. It also offers you Analytics Suite. I think it's a fancy word to tell you that you can actually draw some insights from your code or from your data, and with the OpenSearch dashboards. And a lot of companies actually use OpenSearch not for search engine, but to analyze the logs. So they kind of send the logs there, and it gives you a great overview. Very, very fast. OpenSearch is very fast. So why should you consider OpenSearch? When I think about OpenSearch, I try to actually focus in the superpowers of OpenSearch. So if you think OpenSearch would be a superhero, what kind of superhero would OpenSearch be? So I would say that OpenSearch would speak several languages, because it does have support for more than 30 languages. So for example, not programming languages, human languages, like German, Spanish, Portuguese. So when you're sending your data to OpenSearch, you can specify which language it will be, it's defined for, and it will optimize for search. I also think if OpenSearch would be a hero, it would be able to read your mind, because you can implement auto-completion. I think this is something that you may have seen in search engines. You are typing something and kind of tells, okay, maybe this person is looking for this based on your relevance or some information about you. So this is something that you can also do with OpenSearch. And if you think that OpenSearch could understand so many languages, more than 30, the question would be, can OpenSearch understand my broken English? The answer is yes, because you do have fuzz searching. So even if you mistype something, or if you have small mistakes, OpenSearch still will be able to bring you results. And if you're familiar with different databases that actually you have to provide a mapping or some sort of definitions from the beginning, with OpenSearch you have something called dynamic mapping. What is that? With dynamic mapping, you can just send your data to OpenSearch, and it would figure out what kind of field is in the data. Is it a text? Is it a float? Or any kind of material. So, but you can also define, so you have this flexibility, so it's quite cool. So this would be some of the reasons I would say why you should consider OpenSearch in your project. Now I'm gonna go over some search queries. Actually for that, I'm gonna be using the Python OpenSearch client, lots of data. We are almost in the lunch, so I pick up some recipes for us to work. And you can find it here in this repository. You can scan the QR code, or you can just go in the GitHub and work it. The data looks a bit like this, so you can see the directions like how to prepare the food, and there are several fields here like data, categories, etc., etc. So I will show you now. If you go to the repository, you can see it here in the README. Where did I take this data from? What kind of support is there, or what kind of queries I have it here. So I took the data from the Kaggle recipes, and you can also take it from there. And yeah, you can see it here, how to install and how to get started. So for first, I already have an OpenSearch cluster running, so I'm not going to set up everything. And I already sent the data, but it's also, you can find it here in the repository. How did I do this? So now I will focus on the queries. The first one that I decide to look for, so actually you can just go here and look for help, and it will show up what kind of queries we have it here. So let's go to the first one, is the match query. So if I look for here, and I look in the match, and in the match, I'll be looking in the title for something very exotic. So the most exotic thing I could think about was chocolate and garlic. So that's what recipe that we're gonna try to find out. I'm not sure who would eat this, but I think I would eat this, actually. I like to try new things. So let's see if we can find out something here. So if I press Enter, and you can see it here that actually I do find some recipes. The first one is chocolate garlic, like a toasted bread, and the other ones just have garlic on the title. You must be wondering, like, okay, if I'm looking for chocolate garlic, why is that I'm getting just recipes with garlic? The answer is that when you're working with the match query, there is an operator that by default uses OR. So actually what it's doing is looking for chocolate or garlic, or chocolate garlic. And it will bring those results based in score. So that's why the first one is actually the most, that has the 2 words. But if we want actually to find only chocolate and garlic, we could also define the operator AND. That's what I will do now. Oops, here. So you can see that I found out, yeah, there is just one, and I will definitely try. You must be wondering, like, what is the syntax? I will also show you. So in the match query, the syntax kind of looks like this. So I do have an OpenSearch client, and there is a method called search. And I have to specify which kind of index I'll be looking for. And I write the body with the query, which is a Python dictionary. And here I define which kind of query it is, which is the match one, and which field I'm looking for this. And ta-da, we have it here, chocolate garlic. I have specified the AND operator here. So it's pretty straightforward. Now you must be wondering, for example, if I try out here, if I change the position between chocolate and garlic, I start with garlic and finish with chocolate, would I still get some matches? Do you think I'll still get some matches? Can you raise your hand? Okay, I think everybody knows a lot about OpenSearch. But yes, you would get some match. You still get the same one that we saw. The thing is with the match, the position of the words that you are looking, they are not important. They are not so relevant. You still will bring results. But in some case, for example, if you are looking for someone's name in a database, and if you switch the surname with the name, maybe you end up with someone different. So in some cases, you do want to consider the order of your query. So for that, you would use match phrase. And I will show you with an example what is the match phrase. So if I have here search.py match phrase, and I'll be looking title, and I can define what I'm going to be looking for. For example, if I'm looking for cake, coconut, and we're going to see what we can find. Actually, we don't find anything here. But I'm wondering, okay, I do have 20,000 recipes. I didn't find anything correct here. Because in the match phrase here, as it is right now, it is looking exactly for these words in this order. Nothing in between, nothing swapped, anything. So of course, if I correct that for coconut cake with the right word in English, I can see some results. And this makes sense, right? But yeah, even if you still want to see, like, okay, the relevance of the is a bit important, but I'm wondering, okay, can I give some flexibility to the match phrase? Yes, so in this case, if we want to correct the previous one and give some flexibility, in the match phrase there is something called slope parameter. So the slope parameter works like this. It's the allowed distance between the words. In this case, by default, is 0, so it means that these words have to be in this order to actually bring some result. But if I actually now give a slope of 1, it should work. So yeah, actually here you can see that now I found cake with coconut and so on. If I give a slope of 2, it also works. And now we have even more because I'm giving more flexibility how this position of these words would be. But I'm a very visual person, and even with this, maybe it's a bit confusing. What is actually the slope parameter? So I will show you what's the slope parameter. So here is a document that we queried, and this is our query. So in this case, if we try to identify slope as 1, what it tries to do is actually, okay, let me see a combination of this. If I change the position of one of these words, would it still work? Yes. So basically, the coconut could be in position 3, and the distance would be just 1, and it would work. Another example I could give you is like that I fixed the coconut cake or the cake coconut because they are swapped. So if I try with a slope of 2, if you will bring the position 2 to the position 1 and the position 1 to the position 2, and then you will find it. So I hope this was a piece of cake to understand. It's pretty interesting, this kind of flexibility, because you don't expect always that the reader writes exactly what they want. So it's important to give this flexibility. Now I'll be talking about fuzziness, and for that, I try to think about an example that is a bit complicated for me sometimes. For example, I'll be using the match one, and I'll be looking in title for something that sometimes it can get wrong, like the word dessert. So there is desert and there is dessert. And they're very similar. They even sound similar when you say it, but one is salty, I guess, and the other one is sweet. So if I try to mistype here and look for it, so if I'm looking for dessert here, I will probably not find anything because it's incorrect word. But there is something called like fuzziness, which we can define. Let me see if I wrote correct. Has 1, for example, and now we can actually find something. Because the difference between desert and dessert is 1s. So the fuzziness, if you configure it to 1, you will be able to get some results. How would it be in a more conceptual way or more general one? So for example, if words are different, or for example, if you remove words or actually increase words, this all count as one distance. It uses something called Leverstein distance to actually calculate this, but it's pretty straightforward. It's about, this last one is about transpose of two letters that are close to each other, for example. And this is how you calculate the fuzziness. But I think sometimes you just have your data. You don't know how many mistakes are there, or what would be the best way. Actually, there is a parameter called auto that I'll also show you that you can do that for easily. So here's how the syntax works. You have the match, and you have the title, and in this case, you have the query, and you give the fuzziness. And then you can also put auto. So in this case, if I actually have it here, as with auto, it will automatically look for what would be the best fuzziness to be used, depending on the size of the word. So for long words, we're going to use a little bit more, and for smaller words, a bit less. This is important to notice that if you don't configure your fuzziness correct, you may end up with no relevant results. Because if you swap everything, it may become another word and it's not relevant for you. The last one that I want to show you is, actually, I want to try to find out one recipe with Guinness. I know you can't drink it, but can you cook with it? So let's see if we can find something. So I will just use the match one again, and actually I have to specify the file, and I will use match, and I will use title, and look for the word Guinness, which I hope I write correct. If I'm not, you have to tell me. But yes, so for example, this one is quite simple. I'm just looking for Guinness, and match query, it gives you the score. So you see it here. There's Mostarda, which probably not nice, but there are some cakes too here. So I think that's it, but I have just to show you dashboards. So OpenSearch also have OpenSearch dashboards, would be similar to the Kibana ones, but yes, looks like this. You can draw visualizations out of the box, and you can also do queries from there without with REST API, for example. So that's it for today, and you can find the demo here. Yes, thank you.
Okay, so thank you very much for the talk. We do have time for questions, and again, just come to the microphone so that people watching online can also hear it, and people on back. So, yes.
Do you know what the difference is between Elasticsearch and OpenSearch?
From the version 7.10, they are the same. But since then, they are different projects, and they are developing different. So actually, I didn't look so much in the chain of log of Elasticsearch, more what was the last release of OpenSearch.
Thank you.
Welcome.
So do you have any other question in the room? Yes.
So you are saying that we can replace Elasticsearch with OpenSearch.
Is a question, right? It depends on your user case, because there are some plugins or some things that they didn't allow compatibility. So it really depends what kind of tools are you using. But from the client, if you are using a way to migrate it, like if you're already in the latest one, you have to go back from Elasticsearch version 7.10 and then do the migration to OpenSearch 1.0.0 and then go to OpenSearch 2.0.0. That would be what I would do if I would be migrating clients.
Okay, thank you.
Welcome. Actually, our OpenSearch maintainer is also here, so if you have more questions, you can also talk with him. He's right there. Yes, thank you for your contribution.
So, do we have any other questions?
They are hungry.
We do have a few minutes.
No, it's okay. So if you want to talk with me, we can also talk after the talk. Thank you very much.
Okay.
Thank you. Oh my God.
Okay, ready? Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and
Okay, so welcome back, everyone. So we are here for the final talk on this slot, and this is game development with CircuitPython, and it will be presented by Radomir Dopirowski here. So he's a Python programmer and electronics hobbyist, and also into CircuitPython. So enjoy, and the floor is yours.
Hello, everyone. I'm Radomir Dopirowski, and in my free time I like to play with CircuitPython, maybe build those nice, cool devices and program them. But why would you want to make video games with those? Basically, when you go to an opera or when you go to a rock concert, you can see that there are all those professional people who worked for weeks or months to make together to make that event happen, or even at a conference like this. You have a lot of work put into a single event. And that's a little bit like an AAA game that you normally buy from a shop and play. This is a huge effort of a large number of professional people who do it full time. But sometimes that's not the only way to listen to music, to go to a rock concert, right? You can go to a pub and have some live music in there, or even have a jam session with your friends, or there is a busker on the streets just playing whatever instrument they play just on the street. And this is the kind of game making I'm thinking about, not the AAA professional thing where you spend 2 years, 100 people putting their efforts together, but just a single person sitting down and in 2 hours having a snake or a Flappy Bird or whatever it's still super fun. It's still, you can still do it with friends, and it's super satisfying, and it's a great way to learn. I have some rationales in here. Basically, if you want to do it with Python on your computer, there are all those hoops you have to jump through. It used to be much worse. Now you have the new editor, you have Pygame 0, you have all those tools that make it a little bit easier. But it's still difficult if you want to, for instance, package your game and distribute it so that others can see it. And somehow you get this feeling in the back of your head that it's not really a real game. Like it still feels like a toy. But what if you could, program your own handheld game console? That's real enough. The games for handheld consoles usually are not that complex. They tend to be a little bit simpler and require less work. Not always, of course. So that's why it's nice to do it in hardware. But why use CircuitPython with that? Well, it's a real programming language. It's not like a block-based or like Scratch or something where you have like half of the job is already done for you. You just have to fill in the gaps. In here, you are really in control. You are really learning how the game works inside. You have to actually write all of the code for it. The Python language is popular for education, so most teachers are already familiar with it. And it's also pretty nice for teaching. There is great documentation for Python itself that translates into CircuitPython. So if you already know Python, you know CircuitPython. And because everything is installed on the device you are going to use, the CircuitPython runs on the device directly. You don't have to install anything on your computer. So if it's a workshop or a lesson, like one-time thing, you don't have to waste your time installing things on participants' computers. You also don't need the permissions. Well, you need the permission to use the USB ports, of course, on the computer, but that's all. And next thing is, you are not going to break your computer. You are not going to, I don't know, install something that makes your computer behave differently. Or you will not have to reinstall your system afterwards. Because all you are changing is that one device you have connected to your computer, and that device also is very difficult to break. Even if you write code that doesn't quite work correctly or somehow corrupts the device, you can switch it off and on again, and it's back to how it was. So it's you can also feel very safe while you're experimenting, and I think that's crucial, that you are free to experiment and do the stupidest things, knowing that you are not able to break the device with your code. Next thing is that because this is Python, this is an interpreted language, you don't have to compile anything. You don't have to create a hex file and drag and drop it onto the device. You don't have to muck about with connecting through some serial or holding the device next to your screen to flash it or something like that. It's just it comes as a disk, and you just see the files there, you edit them. I will show in a moment. And the last thing is portability. So one advantage CircuitPython has over MicroPython is that it has the same interface on every microcontroller that is supported on it. So if you write your code for, say, Raspberry Pi Pico, it will still work with maybe minimal changes for screen or something on the Pygamer or on the PyBatch. To get started, of course, to make a game for hardware, you will need hardware. So how to find that hardware? If you go to CircuitPython's main website, that's circuitpython.org, and go to the downloads page, this is the website, this is the download page. You have a list of every single device that is supported by CircuitPython. And of course, not all of them are suitable for making the kind of games you want. You probably want some kind of a display. You probably also want to have buttons on it, like here, this Pi badge looks promising. If you click on it, you will get some more information about the thing. You will get links to firmware if you need to install it on the device. Some of those devices come already with CircuitPython installed. On some of them, you will have to install it on the device first before you can use it. And yeah, you usually get a link or where you can purchase this device as well. And yeah, I prepared a short list of devices you can use, like those the most obvious, those that have a screen and direction pad and fire buttons on them. Of course, nothing stops you from making games that don't use buttons, use accelerometer, or use the touch screen and so on. So that's not such a full list. Yeah, so this is the part where I show you some of those devices. So I will start with the devices with the simplest one of them. Those are the Pew Pew, which that's actually upside down. And you might be familiar with the badge from EuroPython from 2019. That looks like that. Every participant got one back then. It's basically the same device, it's just a little bit bigger. And yeah, with this, you can use the Pew library that I will talk about in a moment. There is also, if you want like more advanced games, if you want some graphics, you can use devices that have screen on them. Adafruit sells those two devices. One is called PyGamer, one is called PyBadge, and the PyBadge also has a light version and it has a version for machine learning. In there, they also will work, and they come with both the Pew library, so they kind of simulate this 8x8 display on the screen, but they also come with the stage and display I/O libraries that I will explain in a moment. Oh, and I also made a Pew Pew version with the display that you can't get it anymore because it's out of stock. But just as a curiosity, it does exist. And there are also more recent devices, like KittenBot has made this MeowBit device that is kind of compatible with the microbit because it has the same kind of connector on it. But you can also install CircuitPython on it and make the same kind of games as on the other devices. And Pymoroni has made a Pico system. That's a very nice, solid aluminum case and 240 by 240 display. You can also use it with CircuitPython. Yeah, and of course there is always the homebrew option. There are things like display modules, buttons that you can just connect to whatever device you have, whatever microcontroller you want to use. And, 3D print your own case or laser cut it and build your own device from scratch. I will not be covering this, but it's completely possible. There is no magic in that. Okay, we can start with the Pew. So I already told you this is the thing that we used as the badge 2 years ago. We also had some workshops on EuroPython. We will have more workshops during the sprint. So if you are interested in trying this out and getting one for yourself, you can come to the sprints and try working on them with us. They have 8x8 display with pixels that can have one of the 4 levels of brightness, basically, and they have 6 buttons for directions and for A and B, basically. That seems very, very simple and very limited, but you can actually make all sorts of interesting games with this, starting with this snake game, from the Nokia phones, but also Tetris, Sokoban, Boulder Dash. We have Frogger. We have Othello, a logic game with actual computer player that plays against you. You could do checkers, I guess, because 8x8, that's perfect for checkers. So there is all sorts of simple game. You could do Flappy Bird, And because this is only 8x8, you don't have to create your own graphics. So it's super fast for you. There is this problem with making games where people start doing the graphics and they just stay there. And they get stuck in because making graphics is fun, but the goal is to finish the game during the workshop. So if you remove this time-consuming part, maybe it's a bit less fun, but at least you get to finish the game. The devices themselves are pretty affordable. You can get the Pews themselves for about $10 plus shipping. So you also will need batteries for them, of course. And they are open hardware. So if you need your own version of a Pew, you just download the design files, modify it in any way you want, send it to the manufacturer, any manufacturer you choose, and they will make it for you. Right. Sorry about that. The library documentation is literally 1 page of A4 format. But we also have example games in there. We have step-by-step tutorials. And we are working on making more useful materials for teachers, basically, for lessons. By the way, if you are a teacher and you are interested in this, please find me and talk to me, because we only have basically experience with workshops. So any feedback from a teacher, what works in a lesson, what works in a school environment, would be very useful to us. Okay, the next one. The next one is the one that does actual graphics. I can show you. Sorry. Let me switch it on. So this is the game selection menu, and I can, let's say we will select this one. So this is an example game written in using the stage library in CircuitPython. Of course, it also uses some graphics that you had to draw yourself. And yeah, you can walk around, you can shoot, you can jump, you can climb the layer there. Sorry for the... Oh, and you can die, of course. Otherwise, it wouldn't be a game, right? If you can't fail. So this kind of games is what I'm talking about here. And the library itself is already built in Pygamer and PyBadge, and of course the Pew M4. You get graphics. Depending on the device, the resolution is a little bit different, but you can scale it to fill the screen. You get sprites, you get tiled backgrounds, you can display text, and you can do beeps, and that's basically it. But it's all you need. All the sprites, all the graphics you use is 16 by 16 images, so they are pretty fast to draw. There are not too many pixels. You only get to use 16 colors in them, and you get maximum of 16 frames of animation for them. But that's enough for a simple game like this. Right now we only have 2 example games in there. There is not much documentation. There is a learn guide in the Adafruit system, but it's just a bouncing ball. We don't really have tutorials for a proper game. We are working on that. It's a community effort. How it actually works. So if you look at the screenshot from such a game, you can see there is actually quite a lot of detail. The problem with microcontrollers is that you don't have that much RAM memory on them. Like the smallest devices I use only have 32 kilobytes of RAM. That's not enough to even fit the image of the screen in that. So how do you display anything if you can't even fit your pixels in your memory? The idea is that you divide your screen into tiles, and each tile uses a smaller picture, and because those pictures repeat, they use much less memory. And here you can see we have two layers of those tiles. One is doing the blue background and the ladders in there. And the second one is actually shifted by half a tile to easier make the corners of the bricks in there, and uses a different set of 16 by 16 tiles. And then on top of that, of course, you don't always have things that align to tiles. You want to have things that move freely, like the enemies and the player character and so on. So on top of that, you can also have sprites. And those layers can be mixed in any order you want. So you can have tiles that are in front of the sprites as well, and you can have text in there as well. So that's the basic idea with this. The graphics are actually BMP files that contain 16 frames in each of the file. And yeah, those are the example ones from the game. Except I replaced the pink background with white because the pink color is a special color that is transparent in this game engine. So yeah, as I said, you use BMP or GIF files, actually GIF files. The proper pronunciation is GIF. And the pink color is transparent. If you need to have something pink but not transparent, you need to make it one-off, a little bit less pink than usually you can't tell the difference by looking at it. You can create the sprites themselves using the Asprite or LibreSprite open source programs, or you can even use Piskel, which is a web-based graphics editor for sprites. So that's you still don't have to install anything on your computer. And you also have sound. You can play wave files. And the easiest way to generate like computer game-like sounds like beeps and laser sounds and things like that is to use a utility program that's called SFXR. It also has a web-based version, so you also don't have to install it. You have a lot of, knobs to turn there to generate the exact sounds that you like, and then it generates a wave file that you can use. And then, of course, you will have to make some maps for your game and things like that. And here the engine doesn't help you. You will have to be creative and either use text files or maybe JSON or whatever to make those for yourself. To actually get the details on how to use this this state library, there is a URL in here. I won't get into details. I won't be showing you code because we simply don't have enough time for this. And the last way I want to talk to you about making games is by using the display.io library. So the state library was written by me specifically to make this kind of simple games like platformers, shooters, and so on. And it has a lot of limitations. Or the sprites have to be 16 by 16. You only get 16 colors. You only get a limited number of layers and so on. I did that all to make it as fast as possible and as fluent as possible in there. But there is a library built into CircuitPython itself that's called display.io that, that lets you do all the same things and more without those limitations. So you get sprites of any size. You get bitmap graphics that are loaded directly from the disk, so they don't use up RAM. You still get sprites and tiles in there, but you also get like vector graphics, shapes, circles, rectangles, rounded rectangles, text labels. You get different fonts you can load. So the state library has one built-in font that you can use. In here you can, just use any BDF font you find. The downside of it is that it's a little bit less fluent and might require a little bit faster microcontroller to run, and maybe more memory as well. But, it's still, and of course it's a little bit more complex to use. So, but it's only for graphics. So your game is usually not just graphics. So you will have to use also other libraries in CircuitPython. But don't worry, they are all there, they are available. There is image loader library that lets you load BMP or GIF files easily. There is Audio Core, Audio I/O, and then either Audio PWM I/O, Audio Bus I/O, or Audio I/O itself for outputting sound. Depending on how you have your speaker connected to the device, you will use one of those. There is Audio Mixer and Audio MP3 for, advanced use for sound. You can have several things making sounds at once, and you can even play MP3 files. If your microcontroller is fast enough for that, of course. And then you have the keypad library and the touch I/O and analog I/O libraries for doing the buttons, or like, fruits used as buttons, or, a joystick, or whatever you need in your particular device. Yeah, so basically that's it. That should get you started. You can find me and you can come to the sprints if you are interested in seeing more details. There is also excellent documentation and excellent help available from Adafruit. Adafruit is the company that develops CircuitPython. It's an open source project, and it's developed in the open, but they hire several full-time developers to work on it, and they pay them for that. So that project is really developing on a good pace. They have a help with CircuitPython channel on their Discord, which is the single best place to ask questions about anything related to CircuitPython. And you can also find me on mastodon.technology. My nick is the Shipu. And if you are interested in my other projects and my hardware hacking, you can go to hackaday.io and search for the Shipu. You can see everything I do with hardware in there. That's everything I have. Thank you.
Okay, so thank you very much for the talk. We do have time for questions. So if you have any questions, you can just walk to the mic so that everybody can hear it. Yes.
Hi, thank you for a great talk. I am a teacher, so I was interested in those links. Have you tried these out at kids clubs at all?
Sorry, can you repeat?
Have you tried out some of these devices with kids clubs, programming clubs, and things like that?
No, so far I have only done workshop with adults, and the problem is I'm not very good with kids. I'm a bit scared of doing this with kids, so that's one reason why we want feedback from teachers. We have made like 5 or 6 workshops with people from all sorts of experience with Python, from Python developers to people completely new to Python, but it was always adults.
Cool. Do you have any other question? Any question from remote attendants? No? Okay. So I got one question just to ask. In the development flow from somebody having an idea of developing some game with CircuitPython and implementing it, could you give us an overview of how that works from, well, implementing some code, I suppose, and then how the workflow comes to that end?
Actually, I can show you how you would do it. That's actually a great idea. I didn't think about it. So I have a micro USB cable here. And I have the CircuitPython, the badge from 3 years ago. I switch it on. It was switched on and it ran out of battery, so maybe I will use a different one. Yeah, by default it displays a menu that lets you select from the games that are already on there. But if I connect it to the computer, and of course the law of live demos. Let's try a different. Sorry about that. Okay, it comes as a disk. And on that disk you can see the Python files that are on the device. Now, by default it will run the main.py file. That's where the menu is coded. You can see the code for the menu here, actually. But if you create a code.py file instead, it will run this by default. You can see the screen is empty because the file is empty. It finished executing that file. I can open it and I can start reading my code. So I will start by importing. Let me make the font a bit bigger. I'm importing the Pew library. I need to initialize it. I will make a screen image that is by default 8x8. I can put a pixel that is at coordinates 3x3 and has color 3, and I can display it on the display. And I will need to have a empty loop at the end, because otherwise it will go to the REPL immediately and we will not be able to see anything. You can see the display is here. The pixel is visible on the device. So if I wanted to make it move, for instance, I would need to check what buttons are pressed, and if say I would move this in here, if keys and Pew.key up is pressed, then Y is reduced by 1. We will put X and Y as the coordinates. We need to initialize them, of course, and we will need to delete the previous let's say position of the pixel, and that should no, we will need, oh, we don't need this line. Okay, that should give us some interaction. And I got an error. Okay, so because we don't have a display here, I can't see the error. So the solution is either to use an editor like Mu that gives you the access to the serial console, or use serial console from the terminal. I can do that. Module object has no attribute get pressed. That is because it's not called get pressed. I mixed up with a different library. It's called keys. Oh, I forgot to show it on the screen, of course. And let's initialize it to something else than 0, 0, because we only have moving up here. So we have our pixel, and if I press the up key, it's very fast, moves up, because I forgot to wait. We can wait for 1/6 of a second to have it move slower. So that's how you begin with the Pew Pew with a very simple game. I can't really show you how you begin with graphics and so on, because this is you start with spending 2 hours drawing your graphics, of course. So we don't have time for that. But we can do that during the sprint if you are interested.
Okay, yeah, that was very clear. Thank you very much for the live demo. Do you have any other question in the room? Yes.
Is there any emulator where you could run this while you get your hardware, in case you start off with a online course while you build momentum for people?
So there is no emulator for the stage and display I/O. I think there is some work on making display I/O work with Blinka. Blinka is an emulator for CircuitPython in general on devices like Raspberry Pi. However, if you go to the we have a Pumulator, which is basically a library that uses Pygame to display this 8x8 display and give you the key presses. So if you just drop pu.py next to your code file and just run this code file with Python 3, you won't be emulating the CircuitPython, it will be Python 3 instead. So some things can be a little bit different, like you suddenly have 8 gigabytes of memory, for instance. But you can develop your games on your computer, and it can also be a bit more convenient that way, so you don't have to, look at the device all the time. However, because of the differences, you are encouraged to also test it on the device at the end, because sometimes I write a game using the Pumulator, and it then doesn't fit on the device, which is a very sad thing.
Thank you.
Okay, thank you very much. Do we have any other question in the room? No? Well, got a final one for you. So when you demonstrated the sprites and the use of assets in the game. So when you are running the game, do you have a runtime that offers you file system, or you need to do something with those assets so that they work on the game?
No, you just copy all the assets to the disk, same as the code. So it's just sitting right there. You can make like subdirectories to sort this, of course, to make it more manageable, but it's just a simple drag and drop thing. Okay. You just have to make sure that BMP files are 16 color, not real, not the 16-bit color, but 16 colors. 4 bits.
Okay, thank you very much. So, last chance for questions. And if not, so let's give our speaker another round of applause. Thank you very much. And thank you very much, Radomir, for the talk.
Thank you.
Take one.
And action. You are actually very serious when you are recording.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython is, well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one. And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython is, well, the people of EuroPython is just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Don't you just say the wrong thing. go into do not disturb mode. That's right.
Hello, how's lunch? Everybody is good?
Oh, cool.
Yes, good. Are you awake? Well, nobody answered, so I'm not so sure. Thank you so much for coming. We have a very exciting education panel here. So first of all, I would like to introduce our chair of today. Is Amy from Microbits, and she would basically ask the panelists questions, and at the end we'll have a session for Q&A, hopefully, if we have time. So yeah, without further ado, I will let Amy take us away.
Thank you. Hi, everybody. I am Amy Fagan from the Microbit Educational Foundation. So for those of you not familiar with the Microbit, it's a tiny programmable computer designed for education. We've got a fantastic brand new Python editor that's going to be launched in about 2 months' time. And you can get a preview of that downstairs in the main forum room. So that's my little plug over with. I'm going to pass along the panel now to introduce our speakers. So I'll go to you first.
Hi everyone, my name is Roisin Faherty. I'm a lecturer in computer science in TU Dublin on the Tala campus, and I'm also part of a research group called CS Inc., which stands for Computer Science Inclusive. And as part of that group, I go out to both primary and secondary schools, but more lately, more secondary schools, doing outreach in computer science.
I'm Sarah Jane Carey. I'm a computer science teacher in Cloisterbreed, which is a large girls' school in Clondalkin. Computer science is a new subject for the Leaving Cert, was introduced 4 years ago. So this will be the first year that we'll have non-COVID proper run at the course. I also work with other pre-service teachers to help them to teach computer science. And in terms of Python, I actually did a Python course with Vicky about 12 years ago to try and teach myself over a weekend. Before computer science was there, I used to do a makey-uppy project-based type thing with my students once a week, and I went in to try and improve my learning. So I literally started learning Python to teach my students. So I'm coming at it like I'm an enthusiast now, but I'm still just a beginner, really, just a learner, and use it to teach the course. So I'm delighted to be here.
Hello everybody, my name is Chris Reyna. So I have a company called Maker Meet. We're makers, you probably might see us downstairs. We have all of the flammable cardboard, which is running a Python game. And we do maker-based education. So we do STEAM workshops and things in both primary, secondary, third level, and beyond, sometimes even preschool, things like that. So a lot of what we do is trying to incorporate many different things of STEAM into one project, and no more than our project downstairs, which is all cardboard with a bit of paper as a screen, but it is running a Raspberry Pi with Python on it. So we try to mix stuff up as much as possible in doing project-based learning.
Thanks, Chris. And we've also got Kelly. Hi, Kelly, joining us remotely. Oh, we don't have sound for Kelly, I don't think.
My bad. Habit of keeping on my mute. Hi, everyone. I am Kelly Schuster-Paredes, and I'm a teacher that codes. I am coming from sunny South Florida, where I'm a middle school teacher, and we teach Python to 6th, 7th, and 8th grade students. And some of you may know me as the co-host of the Teaching Python podcast with Sean Tiber. And I started coding about 4 years ago, and I like to tell everybody I'm really good at teaching kids basic Python. So that's my story.
Amazing. Well, thank you all for being here, and thank you all for being here, both in person and remote. It's great to be here in Dublin at the beautiful convention centre. So to kick us off, I'm going to ask a question to the group. I'm going to pass you, Roisin, and go to you first. But one of the original goals of the Python language was to be easy to learn and intuitive. And these qualities, as I'm sure many of us understand it, it makes it a very effective programming language for education. But I'd love to hear from each of you about your perspective on what other features you find work well in education.
Well, I'll start if that's okay.
Go for it, yeah.
And I suppose I might take a slightly different slant on that question if that's okay. So we use Python to teach CS1 in first year in TU Dublin. And we've had many debates in the department about which language to teach first, C, C++, Java, Python. At the moment it is Python, and it does work well as an introductory programming language. But earlier this week I was at a different conference, and it was very, very interesting to hear a comment from Titus Winters from Google. And he was talking about the gap between education and industry. And it made me think a little bit about the Python language. And while it is really simple for first year coding or CS1, a lot of the detail behind the code is hidden from the students. Just to give one example, you can define a variable and you don't have to know what data type that variable is, which is brilliant because there's no confusion for the students. But Titus's point was that when they get to industry, how fluent are they in the language? Yes, they can solve a problem, but are they solving it in the best way? So I suppose it throws up that question again, and I'm sorry, Amy, it's not really an answer, but it throws up that question again. You know, Python is easy to learn and it's very intuitive and it works well for first year programming at third level. But do we need to look at the bigger picture and where that fits in say, a 4-year degree program, and how to ensure that by using Python in the early years, we also turn out graduates that are fluent in programming so that when they come into industry, they're able to do the jobs that are required of them.
Yeah, fascinating.
In secondary school, we would have students coming in to do computer science in 5th year, and coding is available as a junior cycle subject. So some students, and that's in our school, it's not in every school, so some students might have been exposed to Python. If they've done coding, they'll all have been exposed to Scratch. Most schools try to do a bit of Scratch, and I know that there is Scratch in primary school, and they're doing great work in primary schools. What I find is when they come into 5th year, I'll have a mixed bag of students. Some of them have never done coding before, and some of them maybe have done junior cycle coding, and then some of them might be real enthusiasts and are really big into coding themselves outside school. So you're trying to teach 25 students in a room like that. And I kind of like Python because it's natural, it's English-based, it's readable for them, particularly for the students who've never seen it before. So, and they can get quite advanced, and again, there's always that argument of should we be educating students to prepare them for industry or for education's sake, you know? So from my perspective, Python is a good language to start with because they can get quite far with it, and then we can integrate it into other aspects of the course. Like there's an embedded systems course, part of the course, and they would use Microbit or Raspberry Pi, and we use Microbit in our school, but now that there is Python in the platform, we can use the block-based coding to kind of hammer home the concepts. They can see something happening on the Microbit, the hands-on, that physical thing where, you know, you get the question, why are we doing this? And then I can say, well, you're doing that. So when you walk by this little bit of kit, an alarm will go off. Just a very simple example. But now that we can switch very easily in the platform from block code to Python, I can say to them now, look, this is what it looks like in Python. And it's not such a big gap when we get to actually do the Python section of the course, if that makes sense.
Yeah, absolutely.
Yeah. Yeah, so I would, I suppose my love of Python comes from, again, as everybody has said, in terms of the simplicity of using it and the ease of use to get into. So I suppose I deal with all levels, so primary, secondary, and even third level. In Ireland, anyway, certainly, unfortunately, really Python is, or any text-based language, is rarely seen until the second level. My fervent hope is that because of Python's ease of use in education, as you were saying, it would be amazing to be able to pull that back to primary so that they can start very young, students can start very young, doing block-based, whether it's Blockly, whether it's Scratch, it doesn't matter, and then move to a text-based language like Python. Yeah, the arguments that Roisin said are absolutely true. Is it appropriate for industry? Well, yes, it is, but it's also a tool like any other. Python is absolutely appropriate for certain tasks. Java is appropriate for others. CSS, HTML, whatever language you want to choose is appropriate. Does it tie into databases very well? You could argue that, okay? But in terms of education, the other bonus for me is, as Sarah Jane pointed out, its tie-in to IoT devices or single board computer devices. So again, like the microbit, like the Raspberry Pi, like lots of other boards, it ties directly to that. And for me, as a maker, introducing making and code, it's absolutely perfect to make that leap from block-based languages into text-based languages, because it is that little bit easier to code than other languages are, in my opinion, obviously. Other people would probably disagree with me, but yeah, that's it.
Thank you, Chris. Kelly, I'd love to hear your thoughts on this as well.
Well, I mirror a lot of the comments that have already been made, but I have to say, I mean, this is my only language that I've ever coded, and coming from a non-computer science background, this language just really took over my heart, and it became something that I really just loved. And it was the act of problem solving and critical thinking and finding something that I could connect to that helps me love Python. And that's what I bring with the students. And I find that the libraries themselves allow this diversity and this inclusivity in the classroom. I can pull kids in an interest that they like to be in. I use the Pillow library or Arcade or Turtle or MicroPython library. And just that diversity of all these libraries that are easy to use, easy to access. You can give an 8th grader or a 7th grader this library and get them started is amazing. And then second point I'd have to make is the community. As a teacher who knows, I always tell the kids like 10% of this language, maybe 5%, I need a support group. And the Twitter community has just been awesome, and all the people that we meet on the podcast, if I have an issue and I can't solve with a student, we tend to show the kids, hey, let's use social media. And the Twitter community just, of the Python family, they just love to help out. And so even silly problems that I just can't see the debug, in like 1-2 minutes, they're answering questions for 11, 12-year-olds. So if you can imagine that power of not only teaching Python, but teaching that you can use your passions and you have a whole family to help you, it's just amazing. So that's what I love about Python.
Amazing. You're here. Thank you, Kelly. Any other reflections on what Kelly said there, guys, before we move on?
No, I just think it's a great point. I think it's an absolutely great point, and it's something even I have in my own notes here in terms of the libraries that, again, that plug-in capability or the library's capability just for students also helps because it's the same in block-based coding. Fine, you fire up Scratch. Well, look, you can pull the microbit libraries, you can pull any kind of library you like, and students understand that. And the same is true with Python. Do they understand it in a text-based language? No, not yet, but they will, because they have something to relate it to. And that's just, yeah, absolutely, Kelly, absolutely, it's brilliant.
And just even on the community aspect, as a teacher in secondary school, like there's a very small number of teachers, you know, who would have a computer science degree. Like there's a very small number, and we're looking for teachers to teach computer science. So the fact that you can go on Twitter and ask a question. It's really like the computer science community, the computer science teachers, the tech teachers community. They're so supportive and so helpful. And like you could need that mid-class and literally get the answer by the end of class, which is amazing. I don't know any other subject area where there is that support just from all over the world. You know, just a community of enthusiasts who are so passionate about it that they will help anyone to kind of spread the gospel.
Yeah, it's fab. And what I love about that is that students are seeing that happening live as you're doing it, and that's exactly what the community is all about, which is great.
That's comforting to students as well, to know that they can get answers from a tremendously wider community. It's fantastic.
And to know that it's okay to ask, to see their teacher saying, I haven't a clue. Let's go on here and look this up. And somebody from somewhere will come out, like just to learn that it's okay not to know stuff and ask questions, and somebody will help you.
So empowering for the students to see and to let them know that there's no way that any coder can know everything, and that it's our job to be able to figure it out. And if it means calling on a friend in the Twitterverse, then go for it. So.
Yeah, I have students in third level who would use the community a lot, and you know, especially in first year, they're surprised when they get a response, but the delight of it, and then they're hooked. And that makes my job so much easier. So thank you.
It's great. Oh, I love it. Well, I think that's a nice kind of progression on to our next question, which is, and I'm going to start with you for this one, Kelly, is what are your favorite tools to teach Python, and you know, what resources do you use? Do you find stuff online? And what maybe is missing right now? What have you been looking for, anything that you can't yet find that this community might like to hear about as well?
Well, we, at my school, we make a lot of stuff up as we go. So a lot of our own curriculum. Sure. But I do pull a lot of extra resources. I like to make these things called choice boards, and they allow students to learn in the way that they best see fit. For example, I'll make my own screencast, but then I'll call upon EuroPython short videos or some of the EuroPython articles. We use PyBytes, the newbie bytes, with Bob and Julian. We use the Moo editor, and again, we use the Twitter community. But I find that you can find a lot of things out there, but it just depends on the student and the learner. So I provide a lot of choice on what they can find. One other thing that's really good is the Grok learning platform that comes out of, I think, Australia. Yeah. And so right now I haven't found that there's too much missing. I do feel sometimes that the documentation is a little bit overwhelming to newbies, so I tend to avoid a lot of the documentation. But Microbit just came out with that great new editor with all the documentation kind of parsed out, and that seems to be something easier for the students to look over. I think when they go to that document and there's just text and no pictures, they kind of turn off that website right away. So I try to find videos and short tidbits for them. So.
Great, thank you, Kelly. Sarah Jane, how about you?
Yeah, again, like the level we would go to is probably really basic compared to third level or to all you people in the audience here. But we would use things like there's loads of stuff online, but if I was teaching it, there's a platform called techno.ie that does little bite-sized things that are kind of aligned to the course, and there's one on Python. We'd use something like Code Club. We'd use the Microbit resources to teach specific parts of it, and you're kind of pulling. It's similar to you, Kelly, actually. You're pulling and kind of creating your own course. And we have a book as well, this computer science book from Golden Key Publishing that goes through bits of it. And then what I find is you put something in front of the students and they'll find their own stuff. Like, that's what I like doing in class, go and find a video on this. And we'd use some of the, the YouTube ones that you mentioned. So it's a kind of a mixture of everything. And then we would have certain problems that we would have gotten in teacher training. CS Inc. has a platform that goes through Python and HTML and all the different things that we would need for beginners, and you can use those in class and the students can work at their own pace. Because computer science as a course is very project-based and hands-on, and there's a lot of collaboration, there's not a lot of a student sitting there on their own. It's all group work. So they tend to find what works for them, and then we will share it with the class. So yeah, there's lots out there. And again, because similar to Kelly, like, I don't know, I probably don't know enough to know what I would like. I can't compare it to other languages where I can say, well, that's in that. I'd love if that was there,
Yeah, brilliant. What about you, Roisin?
Yeah, echoing what everyone else has said, really, I suppose. Two different hats on. One, the university hat, I would say, that very much like you, Kelly, we have our own curriculum. We build the resources for that curriculum for the students, and yes, they're drawn from lots of different areas. We would also give supplementary material, things like W3 Schools is great.
That's
as
brilliant,
well.
actually.
Yeah, for some exercises and things like that. So we'd use lots of different resources, different videos, and again, like you, Sarah Jane, I mean, the students tend to find things and share as well with each other and with us, and then we pick out the best of that and follow through. What I'd like to see, and I don't know if there's a tool like this out there, but I find from third level, probably one of the brick walls that our students come up against aside from learning the language, is errors and how to navigate solving an error. So when I get an error, how do I fix that error? And if I get an error, how do I know what that error is? And I think it would be really nice if we had more tools using maybe AI or something that could direct the students to fixing those errors without giving them the answer, because we don't want that, but we want them to not hit an error and go, oh my God, I can't make head or tail of this, and step away from it. And I know from, like say in primary school, they do 3 before me, you know, and we would try and do that as well, 3 different things. But when they hit an error, they find that very difficult to navigate the solution to that. Tracing through, we go through and so on. But if there was a tool or built into Python that would direct them to solving that error, I think that would be amazing if we had something like that.
So you've heard it here first, everybody, if anyone's working on anything.
No pressure, no pressure.
Fantastic.
Don't forget there's the Python tutor. I don't know if you've ever seen that, where you can visualize the steps.
Yeah.
That one was pretty good for debugging. That helped me actually learned a lot.
Yeah, I've seen that, and we do use the debugging tools as well, but I don't know whether it's a mental block that students have. And again, remember, even though computer science, there's been, the Leaving Cert has run for a number of years now, we're still getting a lot of students on the course that may never have done coding before, or not be fully aware of computer science. So when it doesn't work and it stops and you get a box at the end with an error in it, I don't know if it's panic or roadblock or what, but they just tend to just stop. And even though you might show them the debugging tools, they tend to be a little bit intimidated by that in first year, and especially in first semester. So it would be nice if there was something that handheld them through that initially. But yeah.
Chris,
oh, sorry.
No. Or do you have a solution in mind?
Well, interestingly, earlier this morning I had a conversation, and it's a plug. If the guys are in the audience, great. If they're not, go have a look. I've only just met them this morning, so full transparency. But there's a group downstairs called Clean Code, and that is exactly what they're doing. Actually, yes. So they have a debugging tool. It's not just for Python, but it's for all languages. And it's free for personal projects, which seems to cover a wide variety of projects, really. So, and look, I only saw a demo, but it looked pretty cool, actually, to be honest. In terms of tools and things like that, I fully agree with Roisin in terms of like a built-in. I don't want to say a built-in debugger because, but I also just something. Again, I'm thinking almost for younger students.
Yeah.
Not third level, not second level necessarily, but something like that that would encourage them in some way. I don't know what that is. I don't have an answer to that, but I absolutely agree with W3 Schools is brilliant. What else did I put down? The Python themselves, the wiki, Python's wiki is really, really good. It's a little bit text heavy maybe, but yeah, it's still really good for finding information. I really like Developers Google Python site as well, which is excellent. Codecademy as well, used as well, which is quite stepping through processes as well. It's good for kids. In terms of apps, Thonny, absolutely, because it's cross-platform, brilliant things like that. And my absolute go-to is Moo as well, as you said as well, just Moo. And I was lucky enough to meet the Moo creator, my hero, who's sitting over there in the corner waving at the moment, so that's fine. So he's there if anyone else would like to meet him as well. One thing I say, because we teach very diverse across the board, like we might go into a school and have students with Android tablets, or students with iPads, or students with nothing, or anything. I've actually found, and just because I happen to be an Apple educator, it's nothing to do with this, but I have found the tools seem to have, on iOS, have gone from absolutely terrible tools to absolutely amazing tools on iOS. And the step through and the walk through on iOS is really, really good. And just the two, Pythonista and Pyto, are those two apps. They're both, I think, about a tenner, something like that. And, you know, I just found those really good on iOS, frankly. So in terms of creating resources, no more than yourselves, which is interesting, actually. I create my own resources depending on projects and things that I'm doing, or again, it's a little different because we're going in doing a project using that particular language with students. So I will actually create the resources and bring those in and do the screenshots and make the PDF file and provide the PDF file and things like that. So, but it's interesting, we're all creating our own resources for that. I just find that interesting actually. That's kind of, but we're all pulling from very, very similar places. Yeah, I just think that's I wonder why. Why are we doing that? Why can't we pool our resources?
I was just about to ask you that. That was going to be my
Yeah, I
next
think we
question.
should pool our resources, definitely. And why reinvent the wheel?
Yeah.
But I think for me, it's because each year I change my resources, and that is because after a couple of weeks in front of your class, you see who you have, and you're changing the resources to suit the students in front of you, and it's never the same. So you're always trying to give the best to them, so it's constantly changing.
Right. And plus Python 2, Python 3.
Yeah.
I don't have to tell. Yeah, I see some of that laughing down there going, yeah, I know. Yeah.
And I feel that teaching is very personal, so when we are in it and we're pulling out the resources that best enhance what we've just taught, I think it's hard to go, here's my curriculum, you go teach it. It doesn't work that way. So although we pull the resources that we use, giving someone else your curriculum sometimes doesn't work. I know when Sean and I were teaching, we both had the same kind of objective, but the way that Sean taught that objective was completely different than the way that I taught that objective. So it's unique, but yeah, I think that's why teachers pull so much of their own stuff.
Sure, absolutely,
Yeah, the idea of sharing resources is the best way to go about doing that. And still,
we have the people here to do it.
yeah, we certainly do. Right, I'll set up a Google Doc after this. Fantastic. I think we've kind of started to touch on this a little bit already, but the next thing I wanted to ask you all was that if you had a magic wand and you could change one feature in Python, now I have a feeling you've got a sense of what you might say, Roisin, but if you could, I think you probably have, but yeah, if you could change one Python feature, what would it be and why? I'm going to go to you first, Chris, for this.
Okay. Very little, I have to say, very little. I've only ever had one experience, and it wasn't an educational experience, it was a corporate experience in terms of helping, in fact, not even the coding, but helping design the graphics for a project that was being written in Python. And we just ran into, again, I wasn't actually the coder, I wouldn't be that good of a coder to do what they were doing, but it just kept crapping out. It was a memory runtime errors. It just kept going, basically, is all it was. It was only ever once, to be fair, only ever once it happened. And it was a number of years ago, to be fair as well, too. But apart from that, little enough. As a maker, I want to see libraries for everything. I want to see them for microbits. I want to see them for everything. Absolutely everything is what I want to see them for. You know, Arduino, just everything. I want a library for everything. Apart from that, that's all really, to be honest. Yeah, I don't have.
Not asking for much. How about you, Sarah Jane?
Yeah, again, it basically does what we needed to do for the course. And personally, I'm not advanced enough yet. I'm going to say yet, still learning. This time next year, I might have a whole list. But yeah, it does everything we needed to do at the minute. I mean, what Roisin suggested about helping the students see what the error was and not giving them the answer, but like in teaching you have assessment of learning versus assessment for learning. So we want them to learn as they're coming into these difficulties, you know, and work through it. So that would be nice.
Brilliant. Roisin, anything to add?
Not really. I think I'd agree with you, Chris. I think the libraries for everything are really important. I mean, the libraries, we use them all the time as well. And some of the more advanced ones for the AI, the sklearn and things like that, invaluable to us, absolutely invaluable. But yeah, I agree, like there's not much I change in Python. It works for us for CS1, the students learn very well from it. And yeah, if I had a magic wand, that would be it, help them to sort out when they hit a bug like that.
Yeah. Now I'm just checking, I'm not sure if we've lost Kelly. Her picture's disappeared off the screen. She's gone.
Gone for the moment, anyway, yeah.
Okay. Great, we'll just give her a second. Yeah, no, I think, well, I'll go to the next question and we get Kelly back. I'll ask it again. I'm going to start with you for this, Sarah Jane, given you're in the classroom, you're teaching, you're covering the Leaving Cert subject at the moment. What is the biggest challenge you're coming up against? I mean, I know we've touched on obviously bugs and errors and, you know, that resilience that you're trying to help students with, but, you know, anything else to add to that that is a challenge you find you're coming up against when you're helping students engaging with this for the first time, and anything that might help overcome it?
Yeah, well, I think, and I mentioned it before, students who have had no experience of computers or coding. So the challenge as a teacher, and I suppose it's for every subject, is the different levels in the classroom. They do find some of the core concepts are quite difficult for them to get, like something like a variable. Like you spend weeks teaching them what a variable is. You know, recursion, things like that. But then again, the hands-on stuff really helps with that, you know. So when they can see it, you know, and things like storytelling really works with that, you know. So as a teacher, you have to be a storyteller now, as well as everything else, to try and give them examples of what it means. So they're kind of what I would see in the classroom. And then there's the other issues like, and it's not to do with Python or programming at all, it's just the access, you know. So some students wouldn't have access to a computer or something they can work on at home. So in a school, you'll open up labs, you'll have coding clubs and things like that where they can go to. But if they can't practice it at home, it does make a difference, you know. For the course, they have to be doing a lot of work at home. And then, I think that type of thing. And just the other thing is the self-belief. Like it kind of tied into the resilience. And again, I'm in a girls' school, right? So we're lucky we've had a class a year. We had a class a year for the past 4 years since it started, one group. And they choose it as an option for 5th year. But the self-belief that they can do it, like I would get students into the class and they're all different, you know, walks of life, different shapes and sizes, different groups, you know. In high school, you have, in America, you see the films with all the different gangs and all the different types. It's not as marked here, I don't think, but we have different people from all kind of walks of life, and some of them like have no idea what a coder looks like, you know, or they have a specific idea of what a coder looks like, and that's not what it is at all. So you find a lot of the time you're trying to tell them, no, you can actually do this. Sure, look what you did. That's amazing. Keep at it. And that challenge of not feeling bad when they fail. So that takes a while at the start when they come in. You're trying to make them see that it's okay, and you have your posters up. If we haven't failed, we're not learning. You know, the right answer, if you haven't done it 1,000 times and then got to the answer, you're doing it wrong. You know, that kind of thing. And that takes a while to work on. But now we're at it in school. We've had it in school for 4 years. So I think that's breaking down a bit. So those are kind of, I mean, again, it's not Python related, but, you know, they're the
But it's
challenges,
relevant to the subject overall, isn't it? And keeping that interest up and instilling that kind of confidence.
And the success, like building in success. That's why Python is really good for that, because you can show them what success will look like, and they can get success with a program really quickly, you know, whereas some of the other languages, it'll take them a long time. So,
absolutely. Kelly, I think you might have dropped out, and so I'll just repeat the question so you're not wondering what are we talking about. We're talking about just the biggest challenge that you find that students face when you're covering Python with them for the first time, and you know what might help overcome it. So it'd be great to hear your thoughts on, you know, the positives as well as the negatives.
Absolutely. So the biggest thing is that power of yet. We like to talk about the mindset a lot. And of course, the sixth graders, the year 10s, the 10-year-olds that come in, they're happy and excited. You get them to print hello. Their mindset is still positive. They still have this imagination and this ability to, I can do anything. But as you start to get older, the 13, 14, 15-year-olds, they start to understand that I'm not as good as so-and-so next to me. And this mindset of I can't do it. I can't code, I'm not a coder, I can't do math. And so we work a lot on that power of yet, and we talk about climbing the steps and saying that, you know, we're here at the top, and I can't answer all the questions either yet, but one day I will. And we talk a lot about just saying, change that word, I can't code, and add in the sentence, I can't code yet. And it is a good struggle, but it's not just coding that it applies to. So in our classroom, it's not just about learning how to use Python, because Python, God forbid, will be gone in 20 years, and they have to learn another language, or they might be doing some other thing. They need to be able to overcome whatever challenge is put in front of them. And by having an open mindset, a positive mindset, that's going to help them regardless if they're playing basketball, they're doing geometry, they're studying for an AP physics exam. They may not be able to accomplish it, but they will do it one day. So
I really like that thought. It's very uplifting. And I was one of those students not good at maths, technology. Yeah, scary. You know, some of that thinking would have really helped me along the way if it had been happening. How about you, Roisin? Any further to add?
Really excited to hear Sarah Jane and Kelly speak because I've been involved, as I said, primary, secondary, mostly third level. By the time I get them in third level, we have huge problems, especially with females, with imposter syndrome. They feel they can't do it. They feel they're not as good as the boys, and we need to catch that earlier. So it makes me so happy, Kelly, to hear that you're working on it, and Sarah Jane. And I know with CS Inc. I'm trying to work on that too. And it's about kind of breaking down those perceptions. And as you said, the I can't, it's just I can't yet. And seeing that sometimes I can't, you know, or that Kelly can't, or that Sarah Jane can't, and that's okay. We're all still learning. It's a journey. So yeah, I couldn't agree more. I think that is very much a challenge, and at the moment it's a huge challenge in third level, in particular. Interesting, just some of the research I've been involved in. Female students' self-efficacy, which is the same thing, is lower than males. But, and this is the big but, the female students who stick out the degree outperform the males traditionally by the end of it. So very interesting statistic. So if we can get them to believe in themselves, they have the potential to go very, very, very far. And that's just some education research I'm involved in. And then I think the other more mundane challenges that we have, and again, not directly related to Python, but it's always those threshold concepts in first year. So it's the ifs and the loops would be the two big ones. And then when you move into maybe second year, it's moving into more object-oriented and what is an object. And that could be in Python or any language, it doesn't matter, but if the Python community could help with improving or helping us with educating students around those threshold concepts, that would be very welcomed as well.
Great. So yeah, all of your suggestions were welcome. We're looking forward to hearing them afterwards. So thank you, Chris. Any more on that with regards to maybe maker projects and?
Yeah,
you know,
I mean, it's a bigger discussion, and I would sit here all day talking about it. But in terms of what everyone else has said, I can only repeat it, probably not as good, especially in terms of gender encoding. I'm a guy, I code, fine. But I'm a maker, first and foremost. And in terms of, quote unquote, failing at doing something, it's a mindset, it's a systemic mindset, not only in, I would say, probably almost every education system on the planet, but in society as well. And it's women that unfortunately suffer at that mindset. And I'm going to say that bluntly, as a man. And it shouldn't be that way, under any circumstances. I won't relay the story that we were talking about earlier, because it's something upsetting me. But the reality is that it's not about the code. It's not about the job. And this is me speaking with my maker hat on. It's about the feeling you all get when you finish a project or when a bit of code works. And that's a good feeling. It's a positive feeling. And that, as a maker, is, in my opinion, how it should go through if you make pasta and you burn the pasta. That's fine. You failed burning the pasta. Just make it again. And remember, it's only 20 minutes, not 40 minutes, whatever it is, it doesn't matter. The same is true for code. We've all failed at making code. That's okay. But let's encourage other people, everybody, let's help them get through that and do it. And that's a maker mindset. It's not exclusively a maker mindset by any stretch of the imagination, but it's just the mindset of trying to be inclusive of everybody, because it's better for the community. No more, as Kelly was saying, as we're all saying, in terms of the community. Like, the Python community is really an amazing community. It genuinely is. And why can't we share that? I think we should share that. In fact, not only share it, I think we should teach other people how good this community is. And I just feel that that's really important. I just think that's really important. I know it's kind of vaguely off topic. I was going to talk about syntax and stuff, but like, no, but you know, I started getting stuck into that, sorry. But I really do genuinely think in terms of that, it's extremely, extremely important. It's extremely important.
Yeah, absolutely.
I love that, Chris. Can I just add real quick?
Please.
Going in about that mindset, I think it's also that hook, that getting that fail turned into a positive. It's those positive endorphins that's the challenge, another big challenge that I have in the middle school, because I want them to go on to secondary school and I want them to go into the career. But it's my job, I feel it's my job to find that thing that makes them have those positive endorphins. So if it means that one child is doing ear sketch in music and another child is making something in cardboard, like a basketball game with the microbit, and another child's doing something on CircuitPython, my classroom's chaotic and I have a headache when I go home, but those kids are finding their endorphin lighter. And they're getting that stuff that we get when we solve problems. And that's what it means to fail and move on. Because failing and having those negative endorphins doesn't help anyone. And that is a challenge sometimes when people pick up coding. So finding those libraries, those things that make them, that glint in their eyes when they're smiling and saying, look what I made. That's a challenge for every teacher, I think.
I love that, Kelly. We talk about this all the time in the Microbit Foundation, and we call it the microbit moment, like that first exposure where you've coded something and then you've downloaded it into your microbit and it does the thing. And I remember the first time I had that experience, and I was at a bet show like years ago, and I was like so excited. So that, but it doesn't have to be that device. We were talking about this earlier, Chris, around it's device agnostic. It's that feeling almost, isn't it, that you're creating that feeling in whether it's maker projects. It's in third level, it could be wherever, but it's about kind of capturing that feeling, isn't it, and helping others
or
to
pasta, right?
Or pasta, yeah, 100%. I don't know if I'm coming to your house for pasta, Chris, now, to be honest. But
it doesn't matter, I'm telling you, it doesn't matter what you do. What you make, you're a maker, no matter what you make.
Absolutely, absolutely. No, I think that it's really fascinating. I think what I'd like to kind of move on to now just is we're talking a lot about what we can do as a community of Python and educators, but I wonder about policymakers and actual systemic change that we've been talking about being so necessary. Obviously, Sarah Jane, you've been heavily involved in the Leaving Cert subject. Well, you all have your own hand act to play in the way that these things are happening. But I wonder, from a policy point of view, what needs to happen, or what can be done, at this stage to improve things from that kind of systemic point of view.
Yeah, see, it's that's a difficult one, because again, you should have asked me to prepare that question. If I could wish for anything, I want computer science to be in every single school. I want science to be compulsory in every single school. Yeah, it's difficult. I mean, at the minute there's not enough teachers to teach computer science, and that's an issue. So, if anyone here would like to be a teacher of computer science, look into it. There are loads of courses. You could do it outside of your working life. I think there is a lot of work being done, like coding and computational thinking is being introduced at primary school level, and that's filtering through into secondary school, which is great. Yeah. Coding is a newish junior cycle subject. Computer science is a brand new subject. It's just to keep the momentum up. Now, obviously, COVID hit in the middle of it, but to try and get it into every school and to get teachers interested in teaching it, and students and parents to realise that it's not just, in terms of careers, it's not just one particular picture of somebody sitting on a computer all day. Like, it's such it can open up a vast world, and there are countries all over the world now who are introducing just computational thinking to every student. Never mind the coding, just the mindset around it, And even in terms of 21st century skills, like the Python community embodies the 21st century skill of collaboration, like just the fact that you're this massive group working together to promote the subject. We're trying to bring that into every subject, every classroom the whole time. So it is quite difficult, but I mean, you know, that would be my policy change, would be that computer science is offered in every school.
Yeah.
We'll reflect on you saying that one day,
Yeah.
I'm sure.
It's not being recorded. Nobody will see this.
I remember when Sarah Jane told us.
We're
Yeah.
fine.
We will, but remember this date, everybody. No, how about you, Roisin, from your point of view in third level?
I definitely would agree. I think we definitely need more teachers. And I think that's probably one of the biggest problems with the computer science Leaving Cert. But also I've worked very hard through CS Inc. to try and change perceptions of computer science from at primary and secondary level, and we need help with that. Like, we're one small group of 5 people working out of TU Dublin. We've travelled all around the country. We've reached 10,000 students over 3 years, which is great, but it's still not enough. Work has to be done on this to break down the perceptions around computer science so that it does become more open, more equal, more diverse, because we need everybody involved in it. So I think that's definitely something that is huge for me. In terms of policy, I mean, I think the Department of Education has an excellent policy in the Leaving Certificate curriculum. One of their quotes is computers for all, and I think that's really important. And I think we have to always remember that there's always the risk with the Leaving Cert that it becomes an extra subject, or the subject for after school for the elite students. We have to work really hard to make sure that isn't the case. It has to be for all. And then I know my colleague Keith Quill is working very hard in the background too to draw up kind of a policy and procedures for bringing this into primary school. Chris, you'll be happy to hear. And I also think so I think we need the pipeline there. I think we need to look at primary school.
Start early.
Yeah, and even though the coding is there for junior cycle, because it's not part of the formal curricula, that can also pose a problem, because not everybody has to do that, or it's not open to everybody. And sometimes those extra courses, while they're very valuable for people who are interested in them, it's those perceptions. I'm not interested, I'm a girl. You know, we need to expose them to these. So I think it's coming. I think it's on its way, but I think we need a kind of a joined up thinking now between the Department of Education, third level, and industry, and second and primary level as well, to join up and push this through to make sure that we have a fully ecosystem in our education system from primary right through. And primary, that can be cross-curricular, like what you were saying. It doesn't have to be computer science. It can be, you know, computers in geography, computers for history, climate change, looking at all of these different things. So, I mean, there's no reason why we can't bring this in across the full range of our educational system. I'm very passionate about that.
Absolutely. No, and Kelly, I'll come to you as well, obviously with the US perspective, and there's great work going on, obviously code.org, CSTA, but you know, what would you like to see more of, or from an international point of view, you know, how can we all help?
Well, having taught in London and South America and the US, it's pretty much worldwide the same. And I could go on and on about the needs of education and computer science, but I'll stick only for what the Python community can do for us. I mirror all the comments. Definitely finding teachers that can do the job, and getting teachers out of that mindset of I'm a science teacher, because I'm a biology major, and I teach code. So I think we need to tap into those risk takers, those teachers that like to problem solve in their curricular activities, and move them into code. And I think it mirrors what some of the talks that we saw yesterday. Srivasta, he made a really good point that we need to break down that stigma that computer science only works in the computer classroom. Why is that? We read across the curriculum, we do math across the curriculum, we can bring social studies across the curriculum, or civics across the curriculum. Why can't we bring code across the curriculum? So many areas where math and code, and even coding the Constitution. I attempted that. That wasn't very successful. But coding the Constitution allows those students to break down the problems. So one of the things I think that the Python community can do is really be that that source to get the teacher that's not a coder into coding. And I remember the first year at PyCon, I had been coding only 6 months, and everyone was so welcoming, and I kept saying, oh my God, I can't believe I'm here with all these smart people. But why is that? Why is that's the initial feeling when you get into code? I think that needs to break down. Yes, we are all smart people, but everybody's smart in their own sense, and if we work hard at something, we all can code. And I think that needs to be pushed, that it's not just these smart people that go to these great colleges and take computer science all their life and play with computers all their life. It's everyone can do it if they want to. So that's my plea for the Python community.
Amazing. Thanks, Kelly. And Chris, some thoughts on you?
Yeah, I definitely echo all of that. And I'm absolutely heartened to hear Kelly saying that she's teaching Python to 10-year-olds and things like that. Again, exactly as Roshan said as well, and it's great that that you guys are doing that work in order to bring it back, because I just think it's a situation, and that's kind of what we do as well too. I actually don't think it's about the code. As I kind of said before, I think it's about mindsets, as you were saying, and it's about problem solving. It's about critical thinking. It's about lots of other things. All those skills are coding skills, but they're not just coding skills. Those, as you said, Kelly, those are what are required across the curriculum. And I normally speak from the bottom up, if that makes sense, but Amy and I had this talk from the top down from industry. There's a lot of companies, industry leaders, that do not want clones of everybody anymore. Because it costs them a lot of money to hire and then rehire 3 months, 6 months, 18 months, whatever it is, and rehire those people. That costs companies money. But if you have an employee who has a diverse range of skills that is based in critical thinking, then those employees are much more valuable to the company. So if the company changes direction in a year or 2 years or the third quarter of 2025 or whatever it is, then those employees can be kept on and there's no need to retrain or rehire. And that's really important. And as a systemic change, I think those companies need to speak to government and third-level institutions to try to engineer that change and push it down all the way to primary schools so that those critical thinking skills, those 21st century skills, those maker skills, whatever you want, are employed across the board in every single subject because they're valuable in every subject. Are they valuable in coding? Absolutely. But if you're a coder, and I'm sure many of you are, if you're a Python coder, how many other languages do you know? I would suspect most of you know other languages apart from Python. That makes you a much more valuable employee to a company you're working for if you're working for a company. That makes you much more valuable. Well, imagine if you take those critical thinking skills and say, well, yes, I can drive a forklift, I can crunch a spreadsheet of numbers, I can do whatever. So you're not just coders, you have other valuable skills, and I think that needs to be pushed from corporate down. That's my thought.
Thank you, Chris. Yeah, and I think that point around improving diversity in this space right the way through, in research, in third level, in primary, in teaching, that kind of message would really land, I can imagine, where you're thinking, right, I'm good at, there's certain things you can learn, there's certain things you've got a natural aptitude for, and I think it's less scary, I think, if you open people's eyes to that, you can see possibilities for themselves. And I think it's incumbent on us all, I suppose, to think about those messages and how they get out there. We do it obviously within the foundation, but it's, you've got a lot of influencing to do around with parents, obviously with head teachers, as I'm sure you've done. I'm conscious of time, and I could obviously sit here all day having this wonderful conversation, but I think we should definitely go for some questions now from the audience. I think remotely, I'm not sure how we will see them, but they might, nope. No. Okay, well then I think, guys, if anyone has any questions, there's a microphone right there, so please don't be shy. Come on up and ask a question to the group. Yes, please.
Hi, thank you so much for the panel. It was really interesting. I'm a civil engineer and a Python developer, and in my department, in my work, I act as a teacher of Python many times, and I get a lot of questions. So I'm really interested in the things you mentioned of not answering the questions and letting the students find out by themselves. Do you have maybe a rule of thumb that you can apply when to answer, when not to answer? Thank you.
Thank you.
Great question.
That's a really difficult question because every student is different. So I think right back to the primary school rule of 3, 3 before me. So have you tried 3 things? Have you checked the web? Have you traced through your code? Have you, so 3 things before you come to me. And at that point then potentially, again, I think it's more valuable that they see it themselves, so maybe not give an answer but direct, towards this piece of code seems to be causing the problem in this area, have another look. So always be pushing them towards solving it themselves. And I'm in a classroom of 40 or 50 students on my own for 1 hour, I make the mistake of going, oh look, you just missed a semicolon, next person. I'm always doing that, but theoretically it's not the best way to do it. So I would always try and help each other. So if they do team coding, or if there's a buddy system in the organisation, that always works really well as well. And because they're in it together, and then that person has shown me, and then I found something else I'll show to them. So that kind of works, I hope. Sorry, I jumped in to answer that there. Does anyone want to?
That's great.
I can help. I always say Google's your friend, obviously. That's your first source, but we talk about keywords. And I was reminded to mention all the work that Audrey Roberge is doing on the friendly tracebacks. So a lot of the times when students come to me, I make them read the traceback out loud. It sounds like a little childish thing, but Sean always did it to me. He's like, what does a traceback say? What words can you pull from that traceback? And now that the tracebacks are a lot clearer, you can have the students or the learners, adult learners even, what are the keywords in that error? Is it a syntax error? Where is it pointing? And I find that just having them read out loud helps them to start to think about the solution right away. And yes, it is the hardest thing not to give the answer, because you've said it and you can see the problem right there in their face, but they will never learn and do it at home if you help them.
Resist the temptation. Thank you so much, everybody. We'll go to the next question. Thank you.
Hi, thanks very much. I'm a teacher as well, and what you were saying in starting about Python being a nice beginner's language, I think is true. When I come to a conference like this and find out some of the really complex things that Python can do, and that's great as well. But I sometimes struggle with the kind of a middle ground. How do you get students from kind of the prints and simple loops and things onto things like GUIs and the more tricky things? Have you got any recommendations for sort of good intermediate steps which they can take?
That's a perennial problem that we have in TU Dublin. So we would teach Python in first year, and then we jump to the Django framework in second year. And it's something that we're currently reconsidering, because, as you know, we have somebody going from kind of console-based output and then trying to integrate to a framework with GUIs and output. It's such a big leap, so it isn't an easy answer. I think that it's more about how you introduce those, as opposed to, I think it has to be done. So I think our leap from first year to second year still has to be done, but I think it's how you introduce that, and maybe taking smaller steps. So we kind of go straight from the console to the framework, maybe bringing in the GUI before that and then the framework. But to be totally honest, there's no golden answer for that one. It's tricky.
Packaging would be another way. Packaging your Python into an app, depending on what you're doing, obviously. But to try and introduce, okay, you're going to build an app. You're going to build a self-running app. and then now you have to package that and attach the graphics to it, the GUI, you're going to attach everything to it, and that can be a little bit intimidating as well. But yeah, I would agree with you, Roshan. There's no, it's difficult. Yeah, it is difficult. I'm generally at the lower, I say lower end, I don't mean lower end, but I'm generally at the primary, secondary end, so I don't often encounter that. But I would say I do know in terms of sometimes doing things, my experience has just been when I'm starting Python or when I'm doing Python with students and things, it's to a specific goal, and sometimes that goal, Python is not the correct language to use. So what I might then is say, okay, well look, you've used Python, you're vaguely familiar with it, let's try a different language that might achieve this goal better. And that can be a whole nother thing, but then I'm not in a classroom situation, so it's a very different thing as well.
The other thing that does tie things together very well for them is the projects. I don't know if you do any of that, but the project work. In terms of having a set goal, so they define their project, and I think that really helps. And I think once they define the project and the outline of it, then as educators we can direct them to the pathway to integrate more GUIs and the database at the back end, the front end, and the coding in the middle. And I think they're more engaged in it because it's their idea, and that helps a lot as well.
100%.
Great, thank you so much. One last question. Yeah, thank you.
Getting the students to install stuff for the lessons on their machines can take up a whole lesson. What are your strategies for, I guess, picking whether you do everything in the browser in a lesson or whether you get them to install things locally?
I'll take that if you want.
Yeah, please, Kelly, yes.
So the very first lesson I have with 6th, 7th, and 8th grade, mostly 7th and 8th, is investigating their editor and what they're going to use. And they always have to have two choices, one that's online and one that is local on their desktop. So I try to do a screencast, and we use Mu Editor at our school most of the time. So we do a screencast, and I try to get the students to do it at home, because obviously it's going to upload faster when they have everything uploaded at home. And then we also use Colab, which is an online sort of Jupyter notebook, and some students also will choose Replit. So having those two locals and something that they have on the cloud can help. So when, for example, a computer breaks or they have to borrow a computer from their mom or dad, they have an option that is online and they can still work with. So that's what we do.
Agreed, actually.
Yeah, pretty much the same as well. Like we would have used very much kind of like Tanya and PyCharm traditionally, but COVID has just changed everything, and we have to have availability online for students and staff, so that in the event that I'm teaching in a classroom and half of my students are at home, that they can complete the coursework as well. So yeah, it's very much mixed now.
Yeah, we'd be the same except for the actual exam. So the Leaving Cert exam is done on a computer, but they can't have any internet access. So they have to know how to use Tony. You know, they have to have seen it before the end. But we'd have the same. We'd have a couple of things on the go. Yeah.
Okay. Brilliant. Well, that takes us up to time. Thank you all very much for your questions, and an enormous thank you to Chris, Kelly, Sarah Jane, and Roisin for your perspectives. I'm sure there's lots of food for thought for all the members of the audience and all the things you were sharing with us today. And thank you, Kelly, for joining us remotely. You are very much here. It feels like you're sitting with us in Dublin. So
thank you so
hope
much.
to
go watch Kelly's podcast.
Yeah, absolutely. Yeah, absolutely. Check out Teaching Python podcast for sure. But yes, thank you all so much, and thanks to EuroPython and the organisers. This has been very straightforward, which has been a very nice thing. But yeah, thank you all for being here. And a round of applause for our lovely panellists.
And for Amy as well.
Yeah.
Thank you.
Great people, great beer. That would be fantastic.
Today I learned, how to do an interview, I guess. The community, the people, and talking, and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, and but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they said that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action. You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess. The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about...
Hello, everyone. So we are about to proceed with the conference. Thank you all for coming. I'm really glad actually that at EuroPython we have this track about CPython internals and that so many people show up and listen about this, not just how to use Python, but also what's going on inside. And this talk from Sebastian Zeff is one of the most interesting to me, I would say, here. So I'm really glad that I can session chair this one. So please join me in welcoming our speaker.
Yeah, thank you very much for that introduction. So you've made it. We're nearly at the end of EuroPython. I'm so glad that there are still people here. I noticed some people going off to the airport already, so I'm really happy that you're all here. So thank you very much for joining my talk. I won't do an anecdote. I think you've heard enough during the conference. I'll just dive into my talk. I'll first briefly introduce myself, who am I, and then we're going to talk about the actual substance. So my name is Sebastian. I'm from the Netherlands. I live near The Hague. I love it there, and I work for a company called Ordina, and more specifically the Ordina Pythoneers, which is a smaller practice within our company that really focuses on Python development. I'm also one of the codesmiths, which means that I get some time for innovation, for conferences, being here, but also just to explore Python with all the other Python developers at my company, and at other companies as well, just to have a little bit of fun with Python. I think that's really important, to have fun with Python, to really dive into it and make it your passion, at least for me. That's really what I love. In my spare time, I'm one of the volunteers for EuroPython here. This year I was the FinAid lead for the financial aid program, and I also did some session chairing. It was really interesting. I'm really happy that we've made it so far into the conference. And I'm also one of the founders of Python Discord, which is a larger online Python community with a lot of teenagers, but also other folks who are trying to learn Python, discuss Python, and do other stuff with Python. So definitely check it out if you haven't heard about it. Anyway, that's enough about me. Let's talk about Python. So what are we going to do today? Well, basically, we're going to make a journey all the way from the source code of Python to the execution. And for me, it's kind of like writing magic spells. I used to play games like D&D and stuff like that. And with programming languages, you get to write something, and then something happens. Often it's not what I want, but at least something happens. So and that's what we're going to see today. I'm going to take you on a journey. I'm going to show you how Python gets from the source code all the way to the magic, all the way to the execution. I'm not just going to give you a lecture about that. I think that would be rather boring, but I'm going to show you how to implement a new operator in Python, and that will naturally take us all the way from that source code to that execution. However, do note, I have a serious disclaimer for this talk. We have time constraints, so I'm going to omit things. There will be blatant omissions, there will be gross oversimplifications. I will take shortcuts. The implementation will not be ideal, but hopefully it will give you an overview of what happens in the Python internals. All right. If you do like to know more details, if you're interested after this talk, definitely check out the Python Developers Guide on devguide.python.org. It contains a lot of information about how you can mess with the Python internals, how to compile it, but it also has excellent explanations about the parser, grammar, and everything else. And then obviously there's Anthony Shaw's book, CPython Internals, published by RealPython. It's a great book. Definitely check it out if you're interested in this. All right. So what is our journey today? Well, we're going to go from source code to execution basically in two parts. In the first part, we're going to look at the tokenizer and the parser to create something called an abstract syntax tree. And then in the second part, we're going to take that abstract syntax tree and go all the way to the magic using the compiler and the evaluation loop. By the way, if you want to check out the slides or the source code for the version of Python that we're creating today, check out the GitHub repository, everything's there. A couple of versions of the slides, one version of the source code, but do note it's an educational implementation. Don't use it in production. I'm not maintaining it, it's a crappy implementation. Please don't use it for anything serious. All right, what is a pipe operator? Well, a pipe operator is something that's part of a lot of languages, but not Python. And it's basically another way of calling functions. So say you have a function that takes one argument, like this double over here. It just takes a number and it multiplies the number by 2 and it returns the value. Well, the pipe operator allows you to call this function in a different way. You provide the value on the right-hand side of the operator, then you use the operator itself, then you name the function, and then the argument will be passed into the function and you get the result out of it. Well, this is obviously not really interesting. It's just like calling the function double 1. But what you can do with this is you can build pipelines. So you can start with a single value, and then you can pipe it into various functions to process it, and you get something out the other end. So in this case, this would be equivalent to calling double 1, and then insert that into another double call, the nested function call. So this is what we're going to do today. Well, just to be clear, this is not a part of Python. I don't think it will ever be a part of Python. There were a few proposals for this. They were rejected for good reasons. Maybe in the future, who knows, ask a core developer, not me. And the implementation is purely educational. I've already mentioned that. So, the first part, we want to get from the source code, so the characters on the right-hand side, all the way to that abstract syntax tree that you see there. So this tree-like representation of your source code. So if you have a single Python file with this line in it, only this line, you'll get something like you see there, that tree representation of your source code. You have a module, a single expression. It's a binary operation, an operation with 2 operands, a value to the right-hand side and a value to the left-hand side. And that binary operation has a constant, a 10. It has the operator itself, the call pipe, and then it loads a name, the name of the function. Obviously, this won't work in a file on its own because there is no function here, but this is the general idea of what we're trying to do in the first part. We're trying to get from that part to that nice tree over there. So first look at our source code. We humans, we are very good in reading. We recognize patterns, we immediately see that we have a 10, that we have a name double, that we have a weird operator in the middle that is unfamiliar in Python, but at least we immediately recognize the bits. But if you think about it, for Python, at the start, this is just a stream of individual characters. There are 12 characters here, and they make up our source code, and Python has to understand those characters. And the first step Python takes is basically extracting the tokens from this source code. And tokens are the minimal parts that still have a meaning. So for instance, we have a number token over here. If you split this up even further into a 1 and a 0, you lose the meaning of the number 10. We have a name over here. Obviously, if you remove a character, it's no longer the same name. So this is a name token. And the first thing that we need to implement is that Python will recognize this token here in the middle, this operator, this 2-character operator, as one single token. This isn't very difficult to do. This is just a configuration in a file. If you look in the Python repository, there's a file grammar/tokens, and it's just a big mapping of token names to token character sequences. So all that we have to do is we have to add our own token into this file. And there's no meaning here yet. This is just a description of the token, so I've called it v-bar greater, vertical bar greater, and I've mapped it to the token sequence that we want to introduce. This isn't all of it. What we still need to do is regenerate the tokenizer itself, the actual piece of Python that will get these tokens from your source code, because Python will not read this file every time it tries to parse source code. For that, we just have to run some commands, and this will be a recurring theme in this presentation. Change something, run a command, and then you can see the result. So these are the commands. I'm not going to go into detail in all these commands, because you can find them on the internet and you're not going to remember them here anyway. But after we've done this, Python will now be able to recognize our new token, our v-bar greater token. And that's already a big step, but it doesn't really know what to do with that token. So there's no grammar rule that tells Python, if you see this token, then this has to happen. So the next thing that we will need to do is we need to add support for this new token in Python's parser by adding it to Python's grammar. Well, the grammar also has to produce something, which is the abstract syntax tree that we saw earlier. So we also have to tell the grammar how to generate the abstract syntax tree and make sure that there's something for our call pipe available in that abstract syntax tree. So let's look at our grammar yet. So since Python 3.9, the new PEG parser has been introduced. And this has a completely new grammar. It's very flexible, it's very powerful, but we first have to look into the syntax of that grammar just a little bit to add our own rule. So I'm just going to take a very small dive into the parse and expression grammar that Python uses, just enough to know to define our new rule for the call pipe operator. So if you imagine a very simple programming language, and it only has two expression types. It has a sum, and it has something called an atom. And in this very simple language, there are only two grammar rules, the sum and the atom. There might be some other for statements and stuff like that, but we're going to ignore that for now. We're going to focus on these two. Then this is basically what you can define in PEG parser. This is a little bit simplified, but these could be grammar rules. And just to color code them, grammar rules can reference each other. And this is how Python goes down all the grammar rules to see what it matches. So it first starts by trying to match the sum rule, and within the sum rule there are options that reference the atom rule, which is just a number, and that is how we ever consider the atom rule. So if we just have this single piece of source code, it's just a number. It will first try to match the sum rule. It has two alternatives. That's what the vertical bars mean. It has an atom plus an atom, and it has an atom on its own. So this matches the second alternative in the sum rule, which is an atom. Then we look at the atom because it's just a number. So we can parse this. So in this very simple grammar example, we can parse a number on its own. What about this one? Well, in this one, we have an atom, a number, plus, and then another atom, which matches the first rule of the sum. So it's very easy to see that this grammar rule will now be able to match this simple piece of grammar as well. But now what about this one? Think about it for a moment. Are our grammar rules able to parse this very simple statement? I see some people shaking yes, others shaking no. Well, the problem here is that when you start parsing your expression, you will consume these parts. We can parse this very easily. And what we're then left with is a plus and a 3. And we have no rule that matches a plus and a 3 on its own. So how are we going to match something with two pluses? Obviously, we can add another rule. But what if we want an atom plus an atom plus an atom plus another atom? Do we have to add another rule? And if we want 4 pluses or 5 or 6, or if we want an infinite pluses, we'd be busy quite a long time if we wanted to add alternatives for all those different scenarios. But there's a very simple solution for that. And you're probably going to love this. It's just recursion. So what we can do is we can change the first alternative in the sum rule. We can make it reference itself. And now we can have sums that are embedded in other sums, embedded in other sums. And just remember, a sum can also just be an atom on its own. So we can still match an atom plus an atom. But now we can also match a sum contained in another sum. And this is basically all that you need to do to get an arbitrary number of operators in a row. And if you think about it, this is precisely what we need for our new pipe operator. We also want to be able to build an arbitrarily long pipeline, so the grammar rule that we will need to add is a grammar rule that has such a recursive relationship. So let's see that. This is the existing grammar file in Python, grammar/python.gram. Here you see the shift expression if you want to do bit shifting, and you see the sum expression. And I'm just going to insert our new grammar rule between those two. So let's make some space. This probably isn't the best place to insert it, but it means that it's very easy to insert it. So that's why I've chosen it. So here we're going to add a new rule. Let's call it pipe. And as you can see here, this is just our recursive relationship. There's just one problem. Our grammar rule isn't referenced by any other grammar rule in Python. So the parser will never consider it when parsing source code. So what do we have to do? Well, if you look at the shift expression, it actually references the sum expression. That's how the grammar rules flow down. So the only thing that we need to do to insert it, we have to change the references in the shift expression to the pipe one, and in the pipe can then reference the sum one. So if we change this, the shift expression now references the pipe one, the pipe the sum one, and now our grammar rules can flow down again. And this is basically the only thing that we need to do to add our new grammar rule for our new pipe call operator. So now we can parse this, right? We're done. Well, not quite, but because we also still need to be able to create the tree structure that you see there on the right. We have to be able to fit it into our abstract syntax tree. So how are we going to do that? In the old parser, there used to be an intermediate step, the concrete syntax tree, but with the new PEG parser, we don't need that anymore. And the reason why is that because we now have something called grammar actions. If you look here, this is a grammar action between the curly braces, and because we're targeting CPython, this is basically just a piece of C code that is embedded into the grammar file. So whenever Python matches a sum rule, it will then call this C function to create the classes that we see there, to create the tree structure that we see there. Well, to create a binary operation tree structure, we need the right-hand side of the operator, so the value, we need the left-hand side, and we need the operator. So that's the information that we're going to pass into this function, and that we can do by assigning names to the parts that we match in our expression. So we match an A to the right-hand side, pass it into the function, we match a B to the left-hand side, pass it into the function. We know that this is an add operation because this is the sum rule, so we can hard code the add operator, and there are some extra bits having to do with line number and stuff like that. We're going to ignore that for now, but they're very handy for tracebacks and other kinds of interesting things. So this is all we need to create a binary operation with an add operator. Can we now do that for our own rule? Obviously, we can just copy the approach, because our new operator is also a binary operation. So we can just make it call the same function, but instead of using the add operator, we can use the call pipe operator here. Just one tiny problem. The AST uses classes, and there is no class called call pipe yet. It just doesn't exist yet. So we have to create that so that we can actually build this abstract syntax tree with that call pipe node somewhere in the middle for the operator field. So how do we do that? Is that difficult? Do we have to code a lot? Luckily not, because this is another configuration file. This is in parser/python.asdl, which stands for Abstract Syntax Definition Language. And as you can see here, somewhere in the middle, there's a part for the operator, and here's our add option, just in an option list. And this is all you need to do to have a generator create classes for you. So what do we have to do? Just add our new operator at the end as another option. Then we regenerate the AST, we run another command, and now our classes will be created for us. So this is all we have to do to add support in the AST. Now we can regenerate the entire parser, and now we are actually able to parse expressions with the call pipe operator in it. You can see here that we have a binary binop node somewhere in our AST tree, and it actually uses a call pipe class object in there to represent the operator. So this is all that we need to do for the new grammar. And now we're done. Now we can go from source code to an abstract syntax tree. But this is all fairly static. Nothing happened yet. So to do that, we need to move on to part 2, where we're actually going to transform this into something we can run and then actually execute it. So in part 2, we will look at the compiler. So if you've ever joined an online discussion about is Python a compiled language or not, please don't. They're all very toxic. But we are going to compile this into some form of an intermediate language. We're going to compile this into a little bit of bytecode. And to do that, we need to have a bytecode for our new operator, because bytecode is just a long list of instructions for Python, a long sequence of bytes, a long sequence of numbers, and each instruction that we're going to execute has its own number or its own byte, and we need one for our new operation. And obviously, there is already a bytecode for calling functions, but I'm going to ignore that one because it isn't fun to use what's already in Python. So we're going to add support to the compiler by creating our own instruction. Then we're going to make the compiler actually use that instruction, write it into the bytecode, and then we're going to add support in the evaluation loop to actually do something with that code. So let's do that. This is the only Python file that we'll see today. We can use it to define our operation codes, our opcodes. Our opcode doesn't have an argument. Don't worry about that for now, but it means that it has to have a number lower than the have argument constant. So I'm just going to add it here. I'm going to call it binary pipe call. That's for us, so that we can understand it. And the bytecode, the number that we associate with the operation, is 90. Then I have to increase all the numbers below it. That's a tedious job, but we'll have to do it. Now we can regenerate all the opcodes. Do you see the pattern yet? And now the opcode will actually be generated for us. Right, now we have an opcode. Now we still need to make the compiler actually write that opcode into the bytecode. So how are we going to do that? Well, the compiler is just going to visit all the nodes in our AST, and it has functions that handle that visit. And somewhere in our compiler, there's a function called compiler visit expression1, which eventually gets called to handle expressions. We don't actually have to change it, but there's an important fact here. If you look at this function, it's just a massive switch case operations, and for each type of expression, including the binary binop kind, there's a special case. And here's our case. We first are going to visit the left-hand side of the operator, which is really important because we need that value, write all the instructions for it. Then we're going to visit the right-hand side, write all the instructions to evaluate the right-hand side, and then we're going to add the operation for the operator. And to know which opcode to write, there's a helper function, binup, and this is the function that we actually need to change. This is another switch case statement. This will get an AST node, like this add here, and it will return the binup that we actually want to execute or add to the bytecode. So we need to add another case, write our binary pipe call operator, and now we can write it into the bytecode. There's one final thing that we need to change in the compiler. It's the stack effect. Python uses a value stack. You'll see that later. And the effect of our operation is that our value stack decreases by one value. But don't worry about that for now. And this is the compiler. And now we can go from an AST to a long list of instructions. And this is all we need to write our new operator, our new opcode into the bytecode. And now we get to the evaluation loop. And this is really where the magic happens. The evaluation loop, like the name says, is just one giant loop that goes around and around and around and around, executing all the instructions in the bytecode. And inside of that loop, there is a massive switch case statement. And I'm not exaggerating, it's really massive. Look at the source code in python/ceval.c. And for each opcode, it has a case. So for instance, here is the binary subtract. And this is the code that actually gets executed whenever it sees such an opcode for a binary subtract, something minus something else. But here we have a problem, because how do we get the values that were to the right and to the left of the operator? How do we get them back to actually process them here? Well, this is why Python uses a value stack. And from that value stack, we can get the values that we need to perform the operation. Now, how does that work? Say that we have this simple expression, 4 minus 1. What we saw earlier is that Python will first write the instructions to evaluate the left-hand side. When it's done, it will put that value onto the value stack to remember it. Then it will evaluate the right-hand side, and it will put it onto the value stack. And the value stack is really a stack. It will put a 3 on top of the 4 on the value stack, just so that we're able to use them later. So when we enter this new function for the operator, the 3 and the 4 are on our value stack. So now that we can use the pop macro just to get the 3 out of the value stack and make right point to that value. For left, we do something similar. We leave it on the value stack, but we make left refer to that value that's there on the value stack. Now we have our values. We can call a CAPI function, pynumber_subtract, pass in the two values. We get a result out of it. The result will now point to the 1. We are now done with those values. We can decrease the reference counts for the values. And then at the end, we need to do something with the result, with the resulting value. So what do? We just put it back on the value stack. We're going to replace the value that was already there. So after performing the operation, there's one less value on the value stack, and that was the -1 that we saw earlier. Then there's some error handling, and then we do a dispatch to say to the evaluation to please move on to the next value. So how do we do that for a binary pipe call? Well, we just copy-paste this code, because this does basically what we need. We change the targets to our binary pipe call operator. We get the values like we did before, but now we don't want to subtract them. We want to call a function with a value. There's a very handy C API function in Python 3.9. It's not in the long-term stable one, so it might be deprecated, but it's very handy here. And here you can call a function with one argument. And remember, the function was on the right-hand side, so we pass in function right first. The value was on the left-hand side, so we pass it in second. We get the result, decrease the reference counts, and we put the resulting value back on the value stack. And this is all we need to do to get from the AST to the magic. And now we've completed our journey. We can go all the way from source code to execution and all the steps that are in between. There's just one thing left to do. Let's compile our new version of Python. And if you're waiting for it, you might as well just have a sword fight. And after that's done, you can run your new version of Python and you can use your operator. It will actually work if you follow these steps. There are some quirks, especially in operator precedence with this implementation, but it will work in principle. And basically that's it. We've seen a lot of Python internals in a short time. Don't worry about it. This is just for a framework. Check out the books, the dev guide. Source code and slides are available. And if you get weird errors, try running make clean or clean all in Windows and look into something called the magic number, because we've changed the bytecode version, so we need to change the bytecode version in CPython as well. Before we go, I hope you've enjoyed EuroPython. It's been great for me, but we also need to organize the next edition in 2023. I don't know when or where it's going to be, but if you want to be a volunteer just like me, join us to help organize Python 23. You can send an email there, or you can just talk to me after my talk. And that's it. I hope you've enjoyed my talk. Thank you very much.
Thank you very much. Thank you. Wow, wow, wow. I expect we're going to see a lot of forks of Python nowadays. So do we have questions? So when you'll be ready, just queue up and we can, okay, go on.
Just something silly. In the beginning, when you created the tokenizer, you had a symbol there. Did you use that afterwards? I don't remember.
The symbol, the vertical bar and the...
Yeah, the V bar grader.
Yeah. Well, we don't use the name that we can use at the tokenizer output, but we haven't used the name in the grammar. So we haven't used the name, but the token sequence is obviously our new operator. So that's the actual operator that we use.
So why did we give it a name? Because we had to.
Mostly for us humans, to make it readable.
Okay.
So, yeah.
Okay, another one, please.
Yeah. Thank you for the talk. I really enjoyed it. I have like a stupid question. Like every time I'm hear that like the bytecode evaluation is just a loop looking at the top of the stack, it seems so like limiting. Like you have just like one value you can look at. How does it happen that it like has like normal performance? Like it doesn't.
Yeah, it's very interesting. So there are obviously a lot of optimizations in there, but basically this is just kind of like a virtual machine. You have instructions, you have a value stack that you keep track of, some kind of register, and that's really powerful. You can really do a lot with it. So maybe in the Advent of Code, which is an online puzzle, I think in the 2019 edition, you will actually build your own kind of like int code computer using your own kind of bytecode and targets. So I recommend you to check that out and you can really see how powerful it can be. So I'm not quite sure how performant you can get it, but have fun.
Yeah, thanks.
So I don't see anyone else queuing. I have a question though.
Yeah?
So 1 minute to describe what's the magic number.
The magic number. So I actually had a file about this. So whenever Python compiles your code, it will write to a PyC file. You've probably seen it somewhere, and that bytecode is versioned. It has all the instruction numbers in there. But if you're going to change the instruction numbers, then obviously all the old bytecodes, they're no longer valid. They use the old numbers. So there's a kind of a versioning in Python. It's called the magic number, and it will version that bytecode. You can actually change that magic number if you change the bytecode opcodes so that all the old PyC files will be marked as, how do you say that, stale, and it will recompile all your Python. So just to avoid very weird things happening with old bytecodes, with changed bytecodes, it gets a mess. So that's the magic number. Yeah, thanks.
Well, thank you, and this is all the time we have. So please give a round of applause now. Thank you very much. And thank you everyone for coming. And the next thing we have is lightning talks, I believe. So see you all there, I guess. Thank you.
Society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be more community-centered, for us to be more community-centered, how we can help more open-source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different folks, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and other things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming and saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
So hello, welcome. This is the last lightning talks of this week. Please, everyone with a lightning talk, queue there. We need all of you ready to be in the stage. If you are not here, your lightning talk is not going to go live. So please do. Yeah. What time is? By the way, we found a wallet. If someone lost the wallet, it's with security downstairs. Oh, Maria is there. Okay. Yes.
That's you? So then
Yeah.
while he is hooking up, they can go? Or do you need a presentation?
No, I need a presentation. So after this one.
Yeah.
So Europe after this? After this one is, yeah, and then. Okay. Sorry, I need to leave my laptop here. Again, if you have a lightning talk, please stay there with your laptop ready. All the people that was trying to sign last night after the social event to be first in the list, I throw that to the garbage, and I put a new one this morning at 8.
Okay.
You ready?
Yes.
Nice.
Okay.
So, wait. Go.
Okay, welcome everybody. Today I'm Volodymyr Piskun and I'm going to talk about professional vulnerability of software engineers. Yeah, good. Controls work. So I want to start with a question. What is the ability every developer has? To answer it, let's take a look into what is developer learning loop. When you implement something, you begin with learning new things. Then you implement and receive knowledge to the code base, and then you're very likely to have some obstacles. It is not pretty general, though. It depends on your experience and the complexity of the issue. But we all know it. And you repeat it over and over until you die. No, until you solve it. And there is something which is always there when we are struggling with the problems, and it is frustration. While solving a problem, we really frustrate a lot. And while you are growing as a developer, you develop your skills of dealing with frustration. And while we grow, this frustration, which is big and takes all of you, becomes something like this. Small tiny thing in background when you just so focused that you don't really notice that you're frustrated. And with this, you're really getting better at ignoring your own emotions, which is leading to different problems as procrastination or anxiety or even sleeping issues. That could be something else. And one small thing I want to share with you during this lightning talk is that you should never forget to listen to yourself. And for this, you could use different techniques like journaling, or you can just stop for a second and ask yourself, how do you feel from 1 to 5? And how do you feel now, guys? Thank you. Enjoy the weekend. It was a pleasure.
Sorry. Yes. Okay, second one, Marika, Masha, and Lisa from Ukraine, and they're going to share some things.
Hello everyone. We are a small team of junior Python developers from Ukraine, and we are very glad to be here. We have just started our career in software development. My name is Lisa, this is Masha and Marika.
To start with, we want to thank all countries that support Ukraine, especially Ireland that opened their country for 40,000 Ukrainian refugees, continue to help Ukraine in humanitarian aspects using every opportunity. This is incredible, and we're really grateful for that.
Thank you. How can I, sorry. Yeah. I want to share with you my own story about how the war came in my life. On this slide, on the left side, you can see my neighbor's house that I see every day from window in European city. Yeah. On the right side, you can see something, I don't know how it's naming, that was founded on the yard, in the yard of my parents' house near Hostomel. So, and unfortunately, every Ukrainian now have similar story about his parents, his friends, or his own story. For today, there's no single Ukrainian that was not affected by the war. It's pity.
We want to ask you to afford help to help Ukraine. Here you can see a volunteer organizations that we support and we ask you to help. The first organization is based on the church I attend. We are engaged in evacuation of people from dangerous places and humanitarian aid delivery to hospitals, towns, and cities that are in risk or have just been liberated by armed forces of Ukraine. That helps with most urgent needs, such as the reconstruction of houses of people who suffered. The second is shelter for animals that takes abandoned or injured animals from the areas affected by the warfare. Financially, there is no small help. Any sum is appreciated.
And what else you can do for us? Please don't fear to hire Ukrainians, especially young developers like us. We are really happy to have a job. Most of us started our career at the beginning of the war. But many people in Ukraine are not as lucky. It's too hard to find a job in Ukraine at the moment. So please donate, help Ukrainians and help junior developers, especially women. We are really needed. Thank you. We are open for any questions. You can find us somewhere here in the hall after talks. Thank you.
Thank you. Thank you very much. Okay. Sebastian is the next one. What's the name of your talk?
Fuck it.
I'm not going to repeat it. The red one.
The red one? I don't have a told the dongle work.
Yeah, but put it here.
Oh, okay. No bad. Give me 1 second.
Yeah, the projector is not happy with the name of your talk.
I thought this one was better.
Okay, he agrees with you, probably.
Is it good now?
Yes.
There we go.
Go.
All right. Hello, guys. So I'm going to teach you. Oh, 1 second. I'm going to teach you how to fix production code in 5 minutes. So first, let's start a little bit with who I am. I'm a Franco-Mexican Python developer. I mean, I develop in Python. I don't develop Python. Luckily, I'm a numberly data engineer. I'm a pew-pew lover, obviously, and I've been attending EuroPython since 2019. So, a little disclaimer here. If you use this at your job, you might not have a job for a very long time.
Okay. What the? All right. This is what it is. So don't you hate it when you push some code to production, you don't test it because why would you ever do that? And there are some errors that come up and the code doesn't work. Today I'm going to teach you how to fix all that. I'm introducing Fuckit. Fuckit is an official Python library. You can just pip install Fuckit. And then whenever you have a function that fails, you just use the Fuckit decorator and it doesn't fail anymore. Isn't that great? All right, this is good, this is good. Oh, wow, okay. So this package obviously is not developed by me, it's developed by AJ Alt, so you should clap for him, not for me. Please go ahead. And as was written in the official GitHub, but you can't see because it didn't load, this module is like violence. If it doesn't work, you're just not applying enough of it. So you can just chain Fuckit calls and make stuff that still breaks not break anymore. Let's see some examples. So if you have a bunch of code and you don't know which part of it is failing, but some of it is failing, you can just use the Fuckit context manager and all of your failing code will work. And if you have a module and the module is broken, you can just import the module with Fuckit and the module no longer breaks. So yeah, next time your PM, your PO, your CTO, or anyone comes to you and says production is fucked, fuck it. So before I knew what this talk was going to be about, I asked my CTO if he would approve the talk. He said, okay. Please don't fire me. Thank you, guys.
So the PyCon Portugal, come here. Oh, you have slides. Okay, no, wait, then. Next. Sorry. If anyone wants to announce a conference, there is a 1-minute thing that we can do in the middle.
This.
We just like to make your life harder. Yes, after this. Ready?
Oh, okay. And this and
Okay. 5 minutes.
Okay. Hi, I'm Takanori. Today my talk title is "Spread the Community After COVID-19 in Japan." Before main topic, did you enjoy EuroPython? Yeah. I know. I really enjoyed the EuroPython with good people and nice beer and nice beer and nice beer. I'm Takanori Suzuki. Please call me Takanori because Suzuki is a famous family name in Japan. I'm from Tokyo, Japan. Tokyo is far from Europe. I have a question. Do you know Japan? Raise hand. Oh, almost. Have you been in Japan? Oh, 30%. Do you know PyCon Japan? Oh, 10%, 20%. Have you attended PyCon Japan? 1, 2, 3. Thank you. Hi, I'm Vice Chairperson of PyCon JP Association. We launched PyCon JP in 2011. At that time, the Python community in Japan was so small. The first PyCon JP had about 150 participants. Now PyCon JP has grown to 1,000 participants over. Yes. In this year, PyCon JP will be held as an in-person event. Please come to Japan. Have a beer with me. Apart from PyCon JP event, we also work to spread Python in Japan. One is Python Bootcamp, tutorial events for beginners all over Japan. We have held 44 camps with about 800 participants. By the way, I introduced it at the EuroPython poster session in 2019. Does anyone remember me? Oh, thanks. Yeah. Another one is Pi Ladies Caravan. The event connects local women's communities across Japan. However, as you all know, COVID-19 has changed the world. We are no longer able to organize in-person events, but we must not stop our activities spread Python. We have started 2 new activities. The first is PyCon JPTV. We stream YouTube Live every month. We talk about Python news, conference overview, and Python new features and something. It's selfie time. I will present EuroPython at the next PyCon JPTV. I'd like to take pictures with you all and share it on YouTube Live and Twitter. Are you okay? Hey, 1, 2, 3.
Whiskey.
Whiskey. Whiskey.
Nice.
Okay. Thank you. I will share. I will be share. Okay. Sorry. Another one is Python charity talks. We wondered if there was a way to combine our spreading Python in Japan and with donating to the PSF. It is the Python charity talks is the event. It is a half-day online event with all participation and sponsorship fees donated to the PSF. We held 3 events and donated $25,000 over. So huge. Yes. Thank you. In recognition of these activities, board members of PyCon JP Association, including me, won the PSF Community Service Award. Oh, yeah, it was a great pleasure for us. Please check this. Finally, I'm sorry, but I have to say goodbye because I'm now heading to Denmark because the Lego house and Lego land waiting for me. Super excited. Thank you. See you again at PyCon JP anywhere.
Thank you. Chuk? No, you connect your laptop. Yeah, and she's going to announce that we are trying to stream things.
Yeah, perfect cooperation. Thank you.
Yeah.
No laptop. Sorry. Do you want to borrow a laptop?
Sorry, like someone just said that I can do a one minute live stream talk, so I'm just gonna announce a conference that is called Pyjamas Conf. So pajamas, like the thing you wear when you go to sleep, and then conf, C-O-N-F. You can Google it online. I have no slides. So if you Google it, you will still see our website from last year. That is actually, we haven't worked on it yet for this year because people who involved in Pyjamas Conf, most of them are still working for EuroPython, so we have no time to do anything. But I will start working on it probably next month, hopefully. Please search for us again next month, and maybe CFP will be open. The only thing I'm sure is that that conference is going to be online, so you don't have to wake up super, tired and go to the conference venue because there's no venue, and also you don't have to worry about no space to take a nap because you can take a nap in your bed. So that's it.
Thank you, Chuk. That was exactly 1 minute. We don't know drinking Guinness. We are like senior Guinness drinkers by now.
Yeah. It's kind of, I'm not professional, but
Go for it.
I know my stuff. Okay. Hello, I'm Milan Lesnek. I'm from KiwiCom. I'm software over engineer. And I want to start with the beginning, with the story. I have to came here like first from the KiwiCom, and I have to wait for them for 6 hours. So like every normal person, I waited in a pub. And right down, I came there, ordered Guinness, and start checking it. We are from Czech Republic, so Czech style, top down. And the bartender just stopped me. It was the hell in the pub. It was extreme. He just went for me like, I'm mental. What are you doing? Did your mama drop you on the head? And then he told me something like, when he calmed down, that you shouldn't drink a Guinness immediately. And the problem is that the Guinness is a nitrogen-enhanced beer, which is delivered in the glass, which is property with the drug. As you can see, the bubbles are dragged by the glass, and the current is in the middle of the glass. So the problematic part is that the glass contains much more air, and the beer is not that tasteful from the beginning. So we concluded a lot of research, don't worry, is going to get better, I promise. Also, my pride in the pub, the guy is ugly on me, and I'm from Czech Republic, and our consumption is 135 liters per person in the year, including infants and elderly. And I fuck up drinking beer. So research. Every day we are here, we are researching the best what we can do about Guinness drinking, what is the best average time of having to start to drink, how to look the best foam, and everything. Also, we created this beautiful graph about bartender killing intent and Guinness taste. On the average, it's enough to just wait 10 seconds, and the Guinness is completely fine. Sometimes it happens that we have to wait 20 seconds, but it's the worst pub, and you can find out by the price of the Guinness that the Guinness is like 9 euros. So, bartender does not take care anymore in like 9 seconds because he has much more work than just take care of you. The solution. We wanted to create machine learning application like every other to check out the foam, thickness, color, the average price quality of this Guinness, how much you have to wait, and everything like that. So for this purpose, we already prepared a roadmap about research preparation, which happened on the Tuesday because I was here alone, so it wasn't proper research. When my colleagues came, and they are awesome, everyone helped. Every one of them helped a lot. Evening research, it was awesome. Another evening research will happen today. It is planned on the roadmap, and we are searching for the investors today on this presentation. On the Saturday, we are going to research more, Sunday also, Monday also, and on Tuesday, we have to return back, and unfortunately, in the Czech Republic, we don't have a good Guinness. So, call for investors. Current total Guinness cost was 488 euros. And we are going to need approximately 1,000 euros and boards of aspirants. I think 1,000 is enough if we wanted to have 6 beers, everyone, I think. Yeah. 1,000 euros, it's fine. And for the investment, you are going to get whole company, whole research, everything, I promise. So contact me on my business opportunity social medias. You can choose any one of them. I use all of them, except the TVcom email. And let's see. That's it. Thank you very much.
Thank you. Sounds like a really interesting company to invest in.
Yeah, I'm sorry. It was a little bit product placement. I know it's prohibited.
Yeah, it's okay. It's okay. Yeah, it's legal in Dublin.
Yeah, thank you.
Have HDMI?
Yeah, preferably.
No, that's.
You have HDMI?
Yeah, this one.
Ah, perfect. That's better. Thank you.
Yes.
Oops. Yeah. Perfect.
Cool.
Yeah.
Yeah, go.
Okay. Hi everyone, I'm Amar and I'm going to talk about ML. So who here likes ML? Yeah, a couple of people. So probably in the last couple of weeks you've seen something like this. This is called DALL-E Mini. It's an online tool that you can write anything such as llamas visiting Dublin and you will create images. So these are fully generated. And now you might be wondering like, weren't you going to talk about machine learning? And the answer is no, I'm not going to talk about machine learning. It's Friday, I'm going to talk about memes and llamas. And maybe a bit of machine learning as well, just to make this didactic. So this is a Pikachu that looks like a pug. These are llamas participating in a hackathon in Dublin. this is Iron Man, but it's a llama. And now you might be saying, this is probably magic. So what if I told you this is not magic? So right now I'm going to tell you a new kind of model architecture called diffusion models in an elevator pitch. And at the right, you can see some llamas having a rave in an elevator as well. So you say Voldemort and a llama taking a selfie. There is Voldemort, there is the llama, and the selfie. So what's going on? So you have the picture, right? And pretty much these diffusion models, what they do is that they add noise. So they are destroying the picture until you have just a bunch of noise. And then they will try to recreate the original image from the noise. Okay, a lot of text. So you say something, Voldemort and a llama taking a selfie, and then you can use a model called Clip, so like Clippy, to create something called the image encoding. And it sounds really fancy, but it's just a bunch of numbers, so an array of numbers, that has a semantic representation or a representation of the text. And then using diffusion models, you will convert that to the last image at the right. So that's pretty much what diffusion models do. And that's how you can create a sketch of a conspiracy theory that llamas built the pyramids in Egypt. Darth Vader mowing the lawn. Among Us, but the sauce is a llama. Llamas in the Matrix. And llamas and minions attending a Python conference. So thanks, everyone. This demo is open source. It's free. Anyone can go on the web and try it out. And we're having a hackathon for the next week, and you can join. Yeah, thanks, everyone.
Thank you very much. So Christian is next. While Christian is connecting the laptop, PyCon UK is going to do a short announcement. You can use this one, so work with me here.
Hello, EuroPython. After 2 years, PyCon UK is returning to Cardiff in Wales from Friday the 16th till Sunday the 18th of September. Ticket sales are open. Hope to see you there. Thank you very much.
Thank you. So happy to see all the conference.
Damn it.
Yeah, it's okay. There is a few lightning talks that we don't have the speakers, so if you're not here, we are skipping you. And yes, looks like you have a mirror.
Come on.
Yeah, there. Yeah. Perfect.
Do it. Great. Cool. Yeah, it is funny how some Python conferences try to kind of crystallize around a certain topic. And this year, I think it was very much, there was a lot of talk about statically checking your code and formatting your code, and also about type checking. And John Carmack said, who doesn't know who John Carmack is? Show of hands. Who doesn't know what Quake and Doom is? Okay, John Carmack and John Romero actually are the guys behind Quake and Doom. Well, that's just for context. The most important thing I have done as a programmer in recent years is to aggressively pursue static code analysis. Even more valuable than the hundreds of serious bugs I have prevented with it is a change in mindset about the way I view software reliability and code quality. And I think, coming from John Carmack, well, he talks about C and C++ code there, but I think the same is applicable to Python. And yeah, if John Carmack says that, it's good enough for me. Yeah, anyway, I held a talk about around this also, and I just wanted to say my slides up on the this URL, and and I linked and I have a whole link list to refer to the tools I only could I could not really address it in my talk. So I while I'm standing here, I want to say a big, great thank you of the organizers of this PyCon. We came to think about you like our angels in yellow. So thanks a lot, guys. You were brilliant. And I'd like to do another shout out, and that is to all of you guys, to the Python community. You are so warm and welcoming, and you made it for such a great conference. So we came for the language, but we stayed for the community. So sad that we have to say goodbye. But, oh, that is the wrong meme. We'll be back in autumn to PyCon Ireland in Dublin. Thanks a lot.
Thank you. Okay, so we have an announcement here.
Good afternoon, everyone. My name's Parminder. I just want to reiterate the last speaker's comments about EuroPython and how it's been so warm and welcoming. This is my first conference. Just a quick announcement. There will be a social event happening tonight at about 7:30, and there's a small group going out for drinks and dinner. So if you'd like to join us, please meet us outside the convention center around 7:30. All right, thank you. Hope to see you there. Cheers.
Thank you.
Ready?
After trying for 2 days, you have a lightning talk.
Finally. Okay, thank you. My name is Konstantin. You call me Kostya. And I'm going to talk about interviews, tech interviews to be specific. And this is another talk of like 5 hours, squished to 5 minutes, so fasten your belts, please. Sorry. And originally the talk was for interviewers, but I mean, if you're a candidate, it's kind of silly not to listen to advices to interviewers, so I decided to cover kind of both. But first, the first kind of disclaimer. So I'm quite a Penite, and I'm doing a lot of interviews in Kiwi, and Kiwi is large. We have 200 Pythonistas or so, and if you're gonna apply, it's likely that I'm gonna be one of your tech interviewers. But other people have other opinions, and I try to convince them, but they try to convince me, and this is one of the reasons why I'm doing this now, so you can approach me and convince me back. But anyway, I'm doing this talk to convince you too, and I think it's gonna work. So what's the problem with interviews? Basically, you have only a few minutes, a few hours, maybe a few days to figure out whatever the person is okay, and you can work with them, and you're gonna happy working with them. But how can you do that? And it's pretty unrealistic, I would say. So what are shortcuts that people are taking? So sometimes they just assume that if you follow for all of the newest Python changelog changes, then you're gonna know things. But I doubt it. There are people who just follow the same Twitter accounts and memes, and I mean, it just doesn't work in the end. It doesn't show that they actually know something or can do the work. And the other thing is when sometimes people have a lot of questions that are impenetrable, like you can't pass these interviews, and this is somehow a goal of the interview, and well, it doesn't work as well. Of course, if a candidate is smart, they will laugh at you, and if they're really smart, they will find a question that you don't know about, and they will like, okay, so I know what you're doing. So what we are thinking about usually on the interviews, and technically it's universal advice that you can do with anyone who are anxious or in a nervous situation. Make sure they understand what's going on. Be transparent about who you are, what's the structure of interview, what's going to happen, and be clear about everything, and be transparent with issues that they might have during the work, and etc. So our structure of the technical interviews is like this. So first there is a kind of soft part where there is some conversation just going on, and we want to just figure out what are the interests, what the person is having in their mind at the moment. And during the technical interview, we have first kind of a quiz, then we ask to share an opinion, and finally we do some difficult task. So the quiz is just 5 minutes to just clearly verify that person actually talks truth. Because, I mean, if you ask questions on the interviews, sometimes a person can do this, like Google the answer with their phone under the camera. And like with the quiz, you can't usually do that. It's just fast. But it's kind of a ping pong. Questions should be really simple to answer, but not too hard. Like, don't go too deep. It should be fun. Then the opinions part, well, it's about to figure out if the person can learn. So like people have different opinions. Some people have opinions that are not much yours. What we want to learn from this, what we want to figure out, is how people came to this, what they have learned to get with this opinion. But in general, unfortunately or happily, interviewers have to know a lot of things. So I kind of feel like this in this regard. So I can't really help you here. You need to know things to actually test whatever candidate knows technically what they should know. But there are a few tips we can give. So first, if it's a challenge, for junior, you better know the task really well and be able to help the junior really well. So everything goes smooth then. With a senior, well, it's better if you don't know the task. And in this case, we kind of work together, and this feels like the majority. Thank you.
Just in time. Okay, so the next one, while you connect your computer, PyCon APAC is going to do a short announcement.
Hello folks, my name is Iqbal. I've been sent over by our compatriots from in Taiwan to send you a very special and a very important message. I hope I'm successful. My mission is to invite you to PyCon APAC, which is going to be done online on September 3 and 4. There are two important things that we're trying to do within PyCon APAC. Number one is a Young Inspirers session where school children from middle school to high school will present their projects. And number two is sprint talks on this new platform called GatherTown. So I hope you can look online for PyCon APAC, September 3, September 4. Waiting to see you folks join us there. Thank you.
Thank you very much. And the name of this line talk is Trump's Twitter tirade.
Yes. Hey everyone, I'm Peter from a small startup in Hungary called Vizu. And I thought to share a story with you about a former president of the United States who I assume is very popular in this round, specifically about his tweeting habits. So he started tweeting in May 2009. And actually, in the first couple of years, he wasn't such a big user of the platform. So basically, his top month is like 36 tweets. Whereas in the years afterwards, he got hooked on quite well. And then he got to be nominee for becoming the president. As you can see, the closer the election day comes, the more they took away his phone, it seems. So it has a downward trend. And then he won that election and became the president, and there are these, bubbles of growing number of tweets over there. So these are almost all the tweets. I have to admit, these are only for May 2020, and so 6 months is missing before he was kicked out of the platform. And yeah, so yeah, sorry, we're gonna have a glitch now, and it's gonna come back in a second. It's gonna be okay. Just 1 second. Not so much. But yeah, here we are. Right. And let's get back. Okay. So the interesting thing is these were the number of tweets, and this is the number of times these tweets were shared. So you can say no one really cared about the guy before he became a serious nominee, and then when he became president. We call this graphic the Trump Twitter trumpet. Wow, thanks. Okay, so the number of tweets for now. There are obviously three types of tweets: original tweets, retweets, and replies. And if you check the trends, there are some interesting things here. So in the bottom, you can see the replies. That's a function he kind of forgot of after he became president, whereas there is a huge number of retweets towards the end of this period. So basically, this huge growth in the number of tweets comes mainly from just retweeting things. And obviously, he wasn't the only one using the account. So he put in the minimal effort, let's just say, to get there. It's even more apparent if you see the share of the tweets among time. And then another aspect you can take a look at is like what tool he used to send these tweets. First, in the first period, he was overwhelmingly using the web interface, and then he switched to his favorite Android phone. And then when he became president, he was banned from it because of security reasons, so he he had to use the iPhone exclusively, as you can see. If we take a look at the number of tweets in total sent from these platforms, you can see the iPhone is ahead by far. Just another aspect you can take a look at this data set is the time of day Trump sent these tweets. Yeah, it's like a 24-hour clock we see here. AM is on the right, PM is on the left. And yeah, as you can see, there are these famous tweet trends in the early morning hours, so like 78 between 2:15 and 2:30 in the morning. If we filter the results based on the periods that we see in the beginning, so when Trump was still a businessman, he was using the web platform throughout the day, and there were these tweet trends mostly from his Android phone, like, you know, typing in the middle of the night when he got angry, when he saw something on Fox News or, God forbid, CNN. And when he became president, these early morning and night sessions became less apparent. And actually, if you check the peak, so when he was a businessman, let me just go back, the peak is around the afternoon, so around here, it's like 4 in the afternoon. Whereas when he became president, the peak went to the early morning hours, so around 9 a.m. So that was the story that I wanted to share, but there's a catch here, because actually all I used here is a Jupyter notebook to do all this. This is like 400 lines of Python code within a notebook. I put this story together during the conference, and you can do that too by visiting ipyvisu.com. There are two open source packages, ipyvisu and ipyvisu story, with which you can build animated data stories yourself. Thank you very much for your attention.
Thank you. Thank you. Okay.
Can I take a quick picture with the audience?
Yes.
Okay, thank you.
I will disconnect your laptop while you do that. So last lightning talk of today are our friends for the DjangoCon Porto and PyCon Portugal. Yeah, you're welcome.
Hi, we didn't.
So this is the last one. Please don't leave, stay. We have the closing session after this.
So we didn't use the 1 minute opportunity because we wanted to share with you what all of you will be missing if you don't come to Porto this September. We are hosting DjangoCon Europe and the very first PyCon Portugal. We hope to share with all of you our beers. I don't know if they are better or not, but they are good enough. And they are cheaper. Portugal is a country that is not that expensive, so even if you have already come to EuroPython, you probably still have budget for PyCon Portugal. And to leave you with something, you can all apply for a free ticket in this QR code. Hope to see you in Portugal.
Thank you. That looks promising. Okay, that was the last one. In a few minutes, we are going to do the closing session, and then we can all go and cry in the ferryman. See you in a minute.
Giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind, and that's really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, but I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython, and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, networking, and accessories. With Umnitsa, you can automate processes from purchase to end of life, achieving 5 key benefits. Find out how Umnitsa can give you complete control and insight across your technology portfolios. Book a live demo today at umnitsa.com.
Take one.
And action.
You are actually very serious when you are recording me.
What did I learn today? Well, I learned that there is a great Python community in Prague, and it would be great to organize maybe the next EuroPython there. That would be fantastic. A great city, great people, great beer. That would be fantastic.
Today I learned, well, how to do an interview, I guess.
The community, the people, and talking and learning new things. I don't know, it's fun.
We had a really interesting discussion about EuroPython society and how things were before, how things are right now. There were some really interesting conversations about what could be done to be like more community-centered, for us to be more community-centered, how we can help more open source organizations, and more specifically, just be more closer to the community.
So today at EuroPython, I learned about how the new Python versions will be optimized and how they will run faster. I think that's great news for the future of Python.
EuroPython is the gathering of different groups, different thoughts, different ideas, but everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different society, EuroPython society member and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython is, well, the people of EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years.
All right, that was fun. Did you have fun? Yes. Are you tired also? Because there are many volunteers, I'm sure. We're very tired, but I'm sure we're also overjoyed because that was so much fun. We're so happy to have done this. We've been waiting for 2 years, and we've done it. That was... People have been asking in different random channels about stats. Now here they are. Some ticket breakdowns. We have sold 1,194 tickets in person tickets, I should say, and 143 online tickets. I think it was quite interesting to see that the remote participation was not just from people who are not in Dublin. Actually, there were quite a few people joining also from Dublin. I also actually saw quite a few people joining right outside on their phone, which is true spirit of remote, I think. And we have on venue list, we have 247 users. There are quite a lot of chats, over 900 of them. At the same time, there are lots of people also watching on YouTube. The streams currently have been all published on the website. And if you go to the streams, you can probably still see the numbers are growing. So there are quite a lot of people still watching on YouTube. And there were also a lot of people watching live on YouTube and probably on their TV at home. And the gender breakdown, according to the ticket sales, this people who have identified as male, we have sold 834, and female 210, those who identify as other 18. And this is a country breakdown. You can read about it. I'm really glad to see that Ireland is #1. At some point, I was trending not in a good place, so I'm really happy that now Ireland is indeed #1. I think we also saw quite a lot of tickets being sold during the last few days, with Irish developers joining and Irish communities joining in the last few days. I'm really, really happy to welcome so many local communities joining the conference. You can take a moment and look, and you can see that the UK and Germany and Netherlands and US are the top 5. And in April, we ran the talk proposals. We received 429 proposals. And I do believe we broke the record. Vivi, am I right? We broke the record. Yes, we broke the record for receiving #1, like top numbers of proposals this year. And then we went through community voting this year, and we received 23,926 votes. We did not break the record for this, which means all of you will be able to participate in breaking the record next year for us. Because we have been asking people who have joined the EuroPython since 2015 till the current year. Every single year we run community voting. Those who have participated can participate those who had joined in-person conference before or remote in the long-line years, they can participate in the community voting. And this informs us what kind of talks or discussions or topics you would like to see. So please, next year, help us select what you like to see. And out of all of the proposals we received, 29% of the speakers identify as being from underrepresented groups. And this year, we also ran a lot of events outside of the main program. I've listed all of the 8 events over here. I'm particularly proud of the Transcode event organized by Naomi Cedar on Tuesday, and the Makerfest organized by Vicky and Nicholas. Hope you're both here, and Naomi as well. And Vicky and Nicholas put in a lot of effort into making the EuroPython conference maker-friendly. There was a sort of, we were slightly worried that in this kind of conference center, with everything being very health and safety cautious, shall we say, it was not going to work out. So they went through so much effort to make sure that this conference is maker-friendly, and I really thank them for the effort that they put in to prove that we, EuroPython, can also welcome makers, and we would really, really, really like to continue doing that. So in the future years, wherever we go, I would really also like to welcome the maker community to join us, make something wonderful, just invent things with us. And I would also like to report that we have 0 COC incident this year. I think we definitely should welcome Naomi Cedar every single year to do a brief at the opening. That sounds like a really good idea. I would also like to give a report on financial aid. This year, we received a large number of financial aid applications, 130 applications from over 40 different countries. And 110 of these applicants are joining us for the first time, or applying for the first time to EuroPython. and 60 of the applicants identify as a member of an underrepresented group. This year's financial aid budget from EuroPython Society is 20,000, and I'm really grateful for the work of Sebastian and Chuk, who have done incredible work, and Vicky as well, who have done incredible work to make sure every single application is considered carefully. When somebody drops out, we immediately go to allocate the remaining funds to the next. The amount of care that they put in is absolutely incredible. I think this is exactly the kind of community spirit that we should embrace. So thank you very much, Sebastian and Chick. Now, we are experimenting with a hybrid format. As you can see, we have cameras everywhere. Well, not everywhere, but just 2 in every room, but I guess that's quite a lot. So this year, I think it worked. I think a lot of things have worked well in that we involved our streaming team, Gonzo, to have helped us to design a workflow. This is something that I am personally very passionate about, that I think that we could design a sort of workflow that is easy to implement and not too expensive basically to port around. So I'm sharing this wiring diagram that our team drew. This is the implementation of this current year's conference. There are things to improve as well, so you're very welcome to share and to give us feedback. If you're interested in how to do something like this or do something of a smaller scale, or just have good ideas, have ideas about how to motorize some things, we're really looking forward to hearing these kind of feedback. So please just email us, get in touch. We're really, really happy to hear feedback. And this year we're also putting a lot of effort making EuroPython more welcoming for everybody. Theophanes and VB and Diego run a really incredible mentorship program that helps people, especially first-time speakers from underrepresented communities, to learn from more experienced speakers so that they build more confidence to be able to feel that they can speak as well as somebody who are from more privileged backgrounds. And this year we also have a lot of first-time speakers who have benefited from this program. Just want to say great thanks to Theophanes, VB, and Diego for carrying this through, for doing this with great humor as well. Thank you so much. And Chuk on Thursday in the open space also ran a mentor sprint to help people, to help less experienced people feel the confidence to join us tomorrow and Sunday and in the future to sprint with others. In addition, we also made sure that we can make it easy for people to join the conference. So we had free childcare service. This is a picture taken. The babysitter we hired transformed one of the conference rooms to make it more child-friendly, to give children activities to play so that their parents can just come to the conference and have fun like any other people without worrying about how their children are doing. So I'm really happy that we managed to do this very smoothly, and I think this is something that there's no reason why we wouldn't do this every year, because this is something I think quite basic. And we also have pronoun stickers to make people feel that, well, I don't think I need to explain this because these are very basic things. So we have pronoun stickers, and we also have signage in the toilets. We originally wanted to put more signage on the toilets to make non-binary people feel more welcome. This was not very easy to do in the venue, so we decided to just remind people to respect other people's gender identity and expression. And I'm really grateful that we have received no complaints, no incidents. Thank you, really thank you for being respectful. And now for something different. We are having a prize time. I am now welcoming Andrew and Sam from Northern Ireland Raspberry Jam to present the awards for the fastest completion of the robot maze. Take it.
Hello. So Andrew decided to drop out, so he's obviously not here. So I'll be on behalf of him as well. Just a brief explanation. So I'm Sam. I'm part of the many members of a team of volunteers in Belfast who participate and run a Raspberry Jam in Belfast. We would love to invite you all if you want to join us. We have tickets that go out every month, usually during the academic year if you're interested in going. It's usually a family event, so there's nothing like, taking down enterprise networks. If you're interested in that, I feel like there's an event for you. But we hack traffic lights and the such. So if that suits your ability or if you're interested, by all means, there'll be tickets online. Just Google around and you should be able to find it. More importantly, the actual event that or the workshop in the Makerfest was the robot challenge. So the quickest time was 17.5 seconds by brute force, because there's no way you got the sensors to work. Just kind of like rammed against the walls to see how far and how quickly it got round. And I would like to present the award to Hubert Blotowski, and I would like to invite him to collect his prize after the event and for a photo. But thank you so much to everybody who took part. I apologize for equipment, but everybody who took part was fantastic, and genuinely it was a great impression to see all the makers who took part in the event. Thank you.
And I was also reminded to tell you that tomorrow there is sprint, so don't overindulge tonight, because please come over tomorrow, and there will be, somebody must have messed up with the slide. I have no idea what it's supposed to say. In this building, okay. You mess up, right? Refresh. I think we got the gist, Chuck. Yes. So tomorrow, starting at 9 a.m., there will at this bill. There will be sprint orientation. Am I correct, Chuck? No, let's do this. You come and join us. Run.
Sorry, really sorry. It's technical difficulties. We did make the slides, but it doesn't update here. So what happened is that tomorrow there will be sprints in the building. So that will be in the Liffey Hall. Some rooms in Liffey, I can't remember which one, and the Wicklow Hall on the second level. So that will be sprints. So if you want to check out which project you want to work on, please go to our website. Just go to EuroPython website and then find the sprints, and then you can check out all the projects there. All the details are there, and thank you.
/sprints. Yeah, sprints. Yes. And I do believe that you still have time to propose more sprints if you want to. So please go and just tell us all the wonderful or weird stuff that you do. Like, just make a PR there, and then we will merge it. We'll promise to merge it by tonight. And now it's thank you time. I just want to thank all of these volunteers who have been with us throughout the entire year, throughout these very difficult and challenging times to have made EuroPython 2022 happen. So I think some of you have left, and I don't see any of you here, so I'm not sure you're going up. I just want to invite every volunteer who have contributed a lot of their time, a lot of their love and care onto stage, and let's just join the party. So I think Alex is not here, but Alex, I think everybody knows Alex. He is a scheduling master. Yes. So he really designed our program. And Almo is also not here with us. Almo is the person that's basically run all of the remote operators. He designed the whole workflow. He made charts. It's great. He's not here with us, but he will be here with us over there in true spirit of remotes. And Anna Jane and Beth, they are not here either, but they helped Naomi and the rest of the team plan for the transcodes. And Artul, well, he's the infrastructure master. This year, we made a lot of infrastructure changes, including decoupling our program and our tickets, and that's all down to Artur. And Cassie, I hope you're here. If you're not, thank you for all of your work, all of the work you've done for transcode. Everybody knows Chuk, I've already said. So much nice work for diversity and inclusion and FinNate. And Diego is here, yes! And Diego is the person, if you ever see a LinkedIn post, that's him. And Francesco, if something is wrong with our infrastructure, I do not know how he does it, just several seconds later, things are just fixed. And Nico, yeah, this is the guy that just ran the whole remote, making everything so seamless. Thank you so much. And Anders is our treasurer. If anybody ever needs us to pay something, this is a person you should beg. Joanna also helped us a lot with FinNate. Kevin is the COC person, one of the COC person. Lais is the person that designed all of our stickers, and quite last minute, I should say, when I asked her. And I asked her, can you find us a designer? She said, not really, but I will learn everything in one day, and she did. All of the stickers and this big banner, many, many things she designed. Martin, there's a lot of things Martin did to streamline our whole remote setup. And Naomi is the person we go to for advice. That's basically it. And Nicholas is our biggest champion. He keeps us in touch with what the community is really about. Ernesto helped us design so much about the schedule. He gave a lot of inputs for what kind of talks are more interesting. Patrick is the website guy. If you think the website is pretty, that's because of Patrick. And if there is any bug, that's also, well, Patrick will fix it. And Sanger Shannon, all of the speaker tweets that you've seen, all of the other blogs that you've seen, he's part of everything communication related. And Sebastian is the person that just made all these magic with spreadsheets. And then FinNate just magically run without any hassle. And he would follow up every single help desk tickets regarding FinNate. And there's no ticket open currently, I think. 2 tickets open early out of, I don't remember how many applications. So that's him. And Sylvia, I think every sponsor downstairs would want to meet Sylvia because hundreds of emails later, she's still not confused. She just knows who is who out of, we have 23 sponsors. She just knows every single person, answers every single email, and collects all of the data, spreadsheeting. That's Sylvia. And Sylvanus keeps talking about animal facts, and sometimes incorrect ones. And Sylvanus is the person that helped us answer all of the help desk tickets, and if it's not answers, he will pester every single person nonstop, so that every single user of EuroPython is satisfied. And VB, he leads our communication. He co-leads our program. He's the person that looks at pre-talks and just tells people, don't do this, don't do that. This is not correct. And this is why our schedule works for some reason. And this is also why this year we'll have, I hope that you can see that we'll have a much more friendly tone because VB is the chief editor. VB like to sign off with your friendly neighborhood Spider-Man. I don't know why, but I think people like it. And Vicky is the person why we are connected with Ireland. I cannot express my gratitude for Vicky. She loses sleep over social events because we didn't have any social event venue. For a while, she would just go around in Dublin and then just suddenly get new ideas and follow up with every single one of them. And she would recommend all of the great people in Ireland, all of the great-minded people in Ireland, and connect with us. And this is why we feel that this year we belong in Dublin. So thank you so much, Vicky. Thank you so much. And Sayan works with Sylvia and doing sponsoring stuff. And yeah, they're both super organized. Oop, that's not right. And now we have all of the on-site volunteers and remote volunteers, I think, joining us, I hope. If this works, we can see all of the people who are working in yellow t-shirts and also all of the people who you're not seeing because they are somewhere around the world coordinating with all of the people speaking remotely or all of the people who are attending remotely. Woo! Please, let's give them a huge thank you. I think I missed Yasmin from this slide. I just want to say, Yasmin, thank you so much for being with us this whole year. Yasmin has been volunteering with us for 2 years. Last year, she did remote volunteering, and normally, we were not monitoring a lot of different channels of communication. She would be sending message saying, this is spam, that needs to be banned. She just sees things. I do not know how, but she just sees things. And she would be the person who would be the first one to start a newsletter and saying, she doesn't pester people. She just leaves comment and saying, I think we should do this. And then we do that. Yes. Thank you so much, Yasmin. Okay. Do we need to take a picture, or you already done that? Yes. You did that?
One more. You need to be in it too.
Yeah. Okay. Yeah. Let's take a picture.
Where's Nico?
Here. Tall one at the back.
more active, right? Let's raise the hand, something. It looks like school picture.
Still like 15.
Now, all of our volunteers are part of EuroPython Society, and I hope that you, through all our volunteers, through getting to know all of our volunteers, you're interested in also joining the society and help us plan and run the next year's EuroPython. If you're interested in giving us feedback, please email us at volunteers@europython.eu. Or just talk to us tomorrow. Don't get too overindulged. Talk to us tomorrow during the sprints. So see you in 2023 somewhere in Europe. Yes. Now, if any of you has a laptop, take it out and do this. I will give you a second in case you're...
I really want to know what happened. Can you please? X, run, spaghetti.
If you don't have pip X, you can still pip install and run it. That's okay too.
It's so small, I can't see.
In the pocket.
I'm going to project it up there.
What happened?
Is it like you've got anti-gravity
I have to report about it.
Okay, I think you're taking too long. Oops. How do I swipe? Okay, swipe, okay. There it is. Yes. Thank you so much, everyone. Have fun, and tomorrow join us at sprints. Enjoy Dublin. Thank you.
But everybody is sticking together with a common language, which is Python.
Something I really liked learning about, which was really cool, was these VS Code pets, which you can have some pets running around in VS Code. And what I really like about EuroPython is now that we're not remote anymore, is actually talking to people, meeting people, and interacting, and especially comparing developer setups, which we were just doing just now. That's really cool.
During our preparations for EuroPython, I've learned some animal facts, like that giraffes have actually vocals, and they can speak.
Everything everyone does with Python, and that's probably one of my favorite things. And is the surprises you get from, even when you read the abstracts of the talks and you think you know what they're going to be talking about, and then you go to a talk that you think you will not enjoy that much, and it just completely blows your mind. And that's really, really cool.
This year in EuroPython I learned a lot about the streaming and video cameras and all the things.
Knowing people and knowing many different EuroPython society members and Python community members, that I think it's very important if you want to be occupied, if you want to participate in this community, join this community.
I think my favorite thing about EuroPython as well, the people at EuroPython are just fantastic. It's the best people I've ever met.
For me, it's like a nerd camp for all the nerds, so it's really nice to meet all the people that I see only once per year at the conference. Talks are really nice. I learned, for example, about linters for the import statements, which I still have to read about, but I learned quite a lot from that talk.
This year, meeting a lot of friends in person. So I've been in Europe for 3 years, and this is my first time meeting all of you in real life, and that was just amazing.
I got 5 minutes to prepare for a session share, and then after all, I got loads of people coming saying thank you, and they say that they loved it. So I think that was a great job, and I had fun doing it.
I think every day there is something new and funny. I think it's just fantastic.
Highly recommend EuroPython and hopefully see you next year.
Umnitsa is the enterprise technology management solution that consolidates data from existing siloed tools to provide a single source of truth for endpoints, applications, cloud, network.